Permutation combination is one such topic in mathematics which is usually a hit or miss for students. There are few students who love this topic. They are able to solve questions, they get it because their raw thinking ability is very high. While there are other students who are not very comfortable with this topic, whatever kind of classes they do, questions they do, still when the question is framed or put in the exam, they find it difficult to handle it. They do not understand which technique to apply where. So if you are one of such a student who find this topic hard, unable to do P&C, then this video is going to simplify your life to a great extent. I have come up with a different kind of teaching approach in this topic that is based on 24 variations. So a question in P&C can be written in 24 different variations. Once you understand how the same question, which has 24 different variations, can be handled in each of its avatar, you understand what technique to apply where, and you develop a lot of confidence in P&C. And then if you practice questions based on PYQ, largely you will be able to handle questions based on P&C. So this video starts with the idea of syllabus comparison, and then we move towards those 24 variations, which are something unique and I have developed based on my own experience. We understand all the problem solving techniques in this chapter, and then we move towards a survey of problems of JEE Mains for the last 3-4 years. In that, I have divided the problems into 12 problem categories. In each of these problem categories, you will understand what is the type of problem and what are the techniques that we can use in that problem category to come up with an answer. So let us start with it. So let us start this video by having a syllabus comparison of syllabus between 2023 and 2024. If you look into this syllabus, you can see virtually there is no change that has been done from 23 to 24. The important topic remains fundamental principle of counting, permutation as arrangement, combination as selection, use of NPR and NCR, and then simple applications. Now this do not exactly paints what exactly constitutes this chapter or not. So what kind of problems and what kind of exact theories in this chapter? Let us go into it using a mind map. So if I look into this mind map of P&C, what you will see is the discussion starts with fundamental principle of counting, where we understand when to multiply things, when to add things, what is the box method and how to apply box method to solve questions based on numbers. And you will ultimately see that these number based questions are one of the most important kind of questions that are asked in chapter, and they have been asked so many times. So many types of questions are there. We'll discuss it in detail. Next we move on to the idea of permutation, where we understand the formula NPR and what are the validity or important parameters when the formula is going to hold. Because most of the students know what is NPR, but they do not know what is the validity of this formula. Then what will happen if the repetition happens in objects? How does this formula cannot be applied, and then what techniques to use? That becomes another discussion in permutation. Then we move towards combination. Then there are restricted P&C based questions. What is restricted permutation? Restricted permutation is you place some condition on arrangement. This should be the first letter of the word. This should be the last letter of the word. These three letters should come together. This letter should never come together. All these kind of questions we handle using string method, gap method. And then there are questions based on words like rank based questions that we need to understand how to solve them. Then in restricted combination, like we had restricted arrangement, now we have restricted selection. Again, some conditions will be placed, what kind of selections cannot be made and how to make those selections. In such kind of questions, again, you have questions which are based on at least at most constraints. So in such kind of questions, you need to make cases. Again, we will see a category of problem, how those questions are being made by JEE and how to answer those questions. Then there are questions based on number of divisors and sets and ultimately total number of selections. Then we move towards the idea of distribution, and here you can see there are two types of primary distribution, one in which the objects are distinct and in which the objects are non-distinct. So in first case, there is a peculiar method of solving. In the second case, there is beggar's method, which we generally use to solve questions. And then our discussion moved towards circular permutation and dearrangement. So this is what the general kind of questions and theories in this chapter. But to give you a more tangible idea, I am going to take something very unique that I have developed. How can we take one problem and write 24 variations? See, the main problem in this chapter that most of the students will face is, despite knowing the basic theory, basic problem types, how to solve those, they will get confused that which method to use where, and then what kind of changes are coming in the question and how to cater to those variations. So what I have done, I have come up with an approach known as 24 variations. Using this, you will understand how can we take one question, write 24 variations to that questions, and what should be the technique that will be valid in each of those variations. This will largely help us to tackle the 13 problem types that we'll ultimately come up with, in which the JEE has asked questions in the last 3 years. So let us start with it. So let us start with this 24 variations. So what you can do is, you can understand this, that in any question of P&C, what can happen is the object type can change. So there might be distinct objects like A, B, C, D is distinct. There can be identical objects like A, and then there can be mixture of both like two A's and two B's. So this is one variation that is happening. Another variation that happens is either we are going to do selection or we are going to do arrangement. Both of these things, either combination or permutation. Another variation that can happen is we can do this using all the objects. Like from A, B, C, D, I can take two objects or I can take all the objects. Either you can take some or you can take all of them. And ultimately repetition. So whether the repetition is allowed or not in that case, in that question. So you can see that if I apply my principle of multiplication on it, this becomes 3 into 2 into 2 into 2, 24. So what happens is the same problem I can take, and based on these different ideas, I can write 24 variations to the same problem. So now let us take one very simple problem and see how these 24 variations work out. So the problem is very simple. We have been given 5 distinct letters A, B, C, D, E. Now the first question is, what we are saying is we have to take all 5 and make words such that there is no repetition happening. So if there is no repetition happening, what will be the ways to do it? So now in this case, what you can use is either NPR. So what you can do is you can write the answer directly by saying 5P5, and that is nothing but 5 factorial. Or you can use NCR into R factorial. That is also a very popular method. So what I can do here is I can write 5C5 into 5 factorial. This can also be done. Or what I can use is nothing but box method. Now what is this box method? So what I can do is I can make boxes and then fill them sequentially. So this is nothing but principle of counting. And ultimately we stop putting these arrows and we just make boxes. So what I can do is, now if I have to make a 5-letter word, the arrangement or the order in which the letters are coming is important. So we can apply here principle of counting. And we can write the first box can be filled in 5 ways. Since letter are distinct, 1 is getting used, next can be filled in 4, then 3, then 2, then 1. So if I multiply it, what I get is nothing but 5 factorial. So from here also I'm getting the answer as 5 factorial. So in this method, in this type of question, you can apply any of the 3 methods, you will get the right answer. Now, if I change this question a little bit and say that the question is almost same, but instead of this 5-letter words, I need to make 3-letter words, the repetition is still not allowed. So what I can do is, again, I can write my answer by using NPR as 5P3, or I can write my answer as 5C3 into 3 factorial. This is also fine. Or I can use my box method, and now I have to fill 3 different boxes. So answer becomes 5 into 4 into 3. Now the next problem says that you have to again make 5-letter words, but now the repetition of letter is allowed. So earlier I could not write A, but now in this case I can make words in which the letters are also repeating. Now how many such words are possible? So if I do this again, now only one method is permissible, that is nothing but our box method, because whenever the repetition will happen, NPR and NCR will not be valid. And this is a very important and significant statement that you need to remember. So all I can use is this basic principle of counting. And here if I apply, the first box can be filled is nothing but again 5 ways. And since you can see that I can repeat the letter, the next can also be filled in 5 ways. 5, 5, and again 5. So our answer in this case becomes nothing but 5 raised to the power 5. Now this similar approach can be used in having this 3-letter words where repetition is allowed. So again we can make 3 boxes. And the answer comes out to be 5 into 5 into 5. Again, point to be noted, we cannot use NPR or NCR. See, usually the students will have this habit of throwing NCR and NPR to the faculty or the question maker whenever they see a problem. Instead of this, try and develop a very analytical way of applying methods. What method can be applied where? And more importantly, how are you thinking and using these methods to get to the answer? Now let us move to the second part. That is nothing but combination or selection. So now let us see that we have 5 types of chocolates. You can assume it. We have A, B, C, D, E, 5 types of chocolates. And my first question is, if you have 5 types of chocolates, I am asking you to choose 5 chocolates. You cannot repeat the chocolate. So if you have 5 chocolates, you can take only one of each type and you have to choose 5 chocolates. So the first part becomes really simple. What you can do is you can apply NCR and write 5C5, which comes out to be 1. From common sense also, you can write the answer as 1. Now, if I have to choose 3 chocolates, then the answer will become 5C3. And Now, in the next case, what I'm saying is very interesting. Out of these 5 chocolates, you can choose each one any number of times. As far as I'm choosing 5 chocolates, I can choose A also 5, I can choose B also 5, I can choose D also 5, E also 5, or I can take 3A, 2B, and or I can take 3A, 2B, 3E and 2B, or I can choose any kind of combination that I can think. And so this becomes a very interesting question. And now how to solve this question becomes a very important part. So in such kind of questions, what we will use is we will use something called as beggar's method. So what we will do is we will write small a number of chocolates that we are choosing in small a is capital A plus capital B plus capital C plus capital D plus capital E. So A is number of chocolates of A category, B is number of chocolates of B category, C is number of chocolate of C category, so on and so forth. And what we are saying is their number should be equal to 5. So this, you can assume this question or understand this question like this, that your mother took you to the market and said that you can choose any kind of chocolate as far as you are choosing only 5 chocolates. And then there is 5 different boxes of chocolates placed in front of you. So you can put hand in one of those boxes and take any number of chocolates as far as you are choosing 5. Everything is fine. She will not get worried of your health. So this is what is happening in this question. So what we are saying is A is what I chose from box A, B is something that I chosen from box B, so on and so forth. So what is the method? What beggar's method says is that the answer can be directly written as 5, whatever number of quantities we are writing on this side. So again they are 5, subtract 1 and C5. So whatever we wrote here, we have also written here. Again 5, whatever is on the right hand side, how many quantities are there on the left hand side? -1, and C5, whatever is on the right hand side. This becomes a standard method known as beggar's method, and the answer of this question becomes 9C5. Similarly, if I apply the same method in my third part, I can also get the answer as A plus capital B plus capital C plus capital D plus capital E is equal to 3. So now I will write 3. And then there are 5 quantities on the left hand side. So plus 5 minus 1 C3. This is my answer. Now, if you understand what is beggar's method, our discussion ends here. But if you do not know beggar's method, then let us also discuss how this answer came. So what does beggar's method say? See, beggar's method say that this question, and where we are choosing A, B, C, D, E chocolates in whatever way we want, as far as we are choosing 5 chocolates, is equivalent to another question. That is, if I have beggar A, B, C, D and E, and I have 5 1 rupee coins. So assume you have 5 1 rupee coins in your pocket, and you are giving these coins to this A, B, C, D, E. So whatever is the coin that A will receive, that many chocolates you will choose from box A, so on and so forth. So number of coins distributed in these people is equivalent to the answer to this question. Now how to make this distribution? So for that, what we will do is, we will take this 5, 1, 2, 3, 4, 5 coins, and we'll put 4 partitions into it. So these are the 4 partitions that I'm putting into it. So what is happening is, whatever we are writing here, this will be nothing but number of chocolates received by A or coins received by beggar A. This, what is between first partition and second partition, will go to B. Whatever is between second and third partition will go to D, C, and then D. And then ultimately, whatever is left will go to E. So this is what we are doing. So what we are saying is, see, if you put these partitions in this 1, 1, 1 in this manner, so whatever we are arranging them, their arrangements will be equal to the distribution of coins and will be equivalent to the choices that we want to make. So the number of ways to arrange this would be nothing but, there are total 9 objects, 5 coins plus 4 partitions. The factorial of this, and you can see that if there are 5 identical objects, we'll have to write 5 factorial here, and if there are 4 identical partitions, we'll write 4 factorial here. So your answer becomes nothing but 9 factorial by 5 factorial into 4 factorial, or this can be written as nothing but 9C5. Let us go over it one more time. So what I'm saying is, whatever chocolates I'm choosing from box A, B, C, D, E is capital A, capital B, capital C, capital D, capital E. This is equivalent, so that we have 5 beggars and we are giving 1 rupee coins to them. Whatever number of coins that beggar will receive is equivalent to number of chocolates we are going to pick from that box. So what we are saying here is, if I take this 1, 1, 1, 1 coin and put 4 partitions between them, so number of partitions will always be 1 less than the number of participants that are there. So I have put, since there are 5 objects here, I have put 4 partitions. When I arrange these 4 identical partitions with 5 identical coins, what I get is 9 factorial by 5 factorial into 4 factorial, that is nothing but 9c5. Now there is this one more method known as multinomial method that can also be used to solve such kind of questions, but I will recommend you not to use this method. Neither I'm going to cover this, because for JEE Mains point of view, this method is not useful. Please do not use it. But one method is again there that I can use. There is my third method of solving the same problem. This is known as method of cases. So I can make cases, and this might be useful in solving other questions, not this question particularly. But let us understand how to make cases in this question. So how to make cases is, now what you can do is you can say that if I have to choose 5 objects, all the 5 can be same. So I can start with maximum similarity, 5 same. Or I can have 4 same and 1 different. Or I can have 3 same of one type, 2 same of another type. Or what I can do is I can have 3 same and 2 different. Or what I can have is nothing but 2 same and 1 different. Or ultimately 2 same, 3 different, and then all different. So you can see that the obvious problem with this method that there are a lot of cases, and if you miss on to one of the cases, you will not get your answer. That is the reason I will not recommend anybody this method. This method should be the method of last resort. If you are unable to get something or some way to solve the question, then only use this method, because if you miss on to one of the cases, you are not getting your answer. And that is a terrible thing that can happen to you. Hence, you can avoid using this method as far as possible. But sometimes you'll have to apply, and then whenever you do it, figure out the method to apply in a very systematic manner. So like here, when I'm making cases, you should observe I started with maximum similarity, and if I move towards maximum distinct elements that can be there. So I've put a system into place so that I do not miss out on any relevant case. Now how to do it? So once I have done that, if I want 5 similar chocolates, then what I need to do is I need to choose one box out of 5 and take 5 chocolates from there. My work is done. Second, when I have to do 4 same and 1 different. Now, if I have to do 4 same and 1 different, there are 2 types of chocolates. So out of these 5 boxes, I will have to choose 2. And out of 5, if I choose 2, then let us say that the first box was A, another box was B. So now I have a choice. Either I can take 4 A chocolates and 1 B chocolate, or vice versa. And I can also have taken 4 B and 1 A chocolate. So corresponding to this case, there will be 2 subcases. Next, if I go towards 3 same, 2 same, again I have to choose 2. And again I will have same 2 cases. And in the next one, you can see that now there are 3 same and 2 different. So what I will require, these 2 boxes are not going to cut it. I will require one more box, C box. And in order to do that, out of 5, I have chosen 3 boxes. Now what will happen is either I can take 3A, 1B, 1C, or I can take 1A, 3B, 1C, or I can take 1A, 1B and 3C. So you can see that there are 3 cases corresponding to this. Similarly, in the next one, I can write this as, what I can do is again I have to choose 3, and again there will be 3 cases. Similarly, in the next one, I will have to choose 4, and there are going to be 4 cases. And in the last one, there is only one way. You'll have to choose or 4, and there is only one way. Now you will have to add all of these answers, and then you have to come up with your final answer. So here you should also understand why are you adding it. And this is very important, because what I have seen is a student will again commit mistake in whether to add or to multiply. So here you should understand there are 2 very important ideas known as principle of counting. So what does basic principle of counting does is, it tells us when to multiply and when to count, when to multiply and when to add. So if there are things that are happening in sequential manner, like I have to make a 3-letter word, the first can be done in 3 ways, second can be done in, so you can see that each of this word is part of each of this letter is a part of the same word, and there is a sequential process happening, then multiply. And there can be another scenario. This scenario would look something like this. There is a work and it can be done in case 1 ways, case 2 ways, case 3 ways. Now if something is happening in this manner, which is a parallel logic, then you need to add things. Now if you understand these 2 things, now you can see that here whenever we are making cases, we are going to add things. Inside a case, we are going to multiply it. Now let us summarize what we have learned. If I summarize, what I have done is I have divided my distinct objects wala case into 2 different parts. First was permutation,
and second was combination. Permutation also, there was first case when repetition was not allowed, and in the second case when repetition was allowed. When repetition was not allowed, we can use NCR into R factorial, we can also use NPR, or we can use box method. These are the two methods that are available. But if repetition is allowed, in that case only box method is allowed. You can only use box method in that case. If I have something like combination, and again there are two cases, repetition is allowed, repetition is not allowed. So in case of repetition being not allowed, what you can use is NCR to get to the answer. But when repetition is allowed, in that case we will use Bagger's method. We can use multinomial theorem, but I have said you can avoid in most of the cases, or you can use method of cases. So you have three approaches to solve a question. Now this basic algorithm that I have drawn here, if you remember, most of the times you will face no difficulty because you can figure out what is exactly happening and you can use that technique correspondingly. Now if I move forward, there is this nature of object that has changed. In this next 8 problems, what you can see is we have been given objects that are identical in nature. All of them are A. Now what to do in this scenario? So what you can do in this scenario is, if you have to take 5 objects, repetition is allowed. And if I do this, you can see that whatever way I arrange them, all of them will always look out to be the same because they are exactly identical. If you move their order also, no change will ultimately come. So corresponding to this, the answer is 1. Corresponding to second one, the answer will still be 1. Third one is also 1. Fourth one is also 1. You can see that the answer always comes out to be 1. Similarly, if I do combination also, my answer will be 1, 1, 1 and 1. So what we can realize after doing this is, most of the times these questions will be irrelevant and cannot be asked. But JEE has asked such questions in the paper to just confuse the students, because they will have this tendency of throwing NPR and NCR whenever a question is asked, or some kind of a factorial they will throw. 5 objects are there, how many ways they can be arranged? You will directly say 5 factorial without even understanding the nature of objects, that if nature of object is exactly identical, then 5 factorial NPR, nothing of it is valid. The answer is always 1. Now this next type of category of problems is nothing but based on mixed objects. So now you can see that we have 4A, 3B, 2C and 1D. So the nature of objects is mixed. Some of them are same, some of them are distinct. So this is a very peculiar question category, and JEE has asked a lot of questions on this area and students usually get confused. So let us go into those 8 problems once more. So if I say that out of this, if I have to take 10 and repetition is not allowed. See, when I say repetition is not allowed, what I mean is whatever is given, that much is fine. You cannot repeat more than that. What does that mean is, A 4 times you can use, but 5th time you won't be able to use. B 3 times you can use, or 2 you can use out of that. But beyond that, 4, 5, 6 you cannot do. So this is what I mean when I write here repetition is not allowed. So if I have to choose 10, repetition is not allowed, my answer is going to be nothing but 10 factorial by, that is the total number of objects given here. Since there are 4 A's, so 4 factorial, 3 A's, so 3 factorial, 2 C's, so 2 factorial, and 1 D, so 1 factorial. And if I move to the third part, what is the answer? Now what you will be thinking that, sir, why not second question first? So second question and the combination 6 question I am going to consider at the same time, because they are similar kind of questions. And third, fourth and other questions I will consider first, because these are simpler to do in terms of calculation. So if I do to the second one, what we are saying is 10 letter words, repetition is allowed. So see, now what you think, what the thing that you should think is, let us refer back to our earlier case. When repetition was allowed, what was the method that we used there? The same method we are using here also. And that method was nothing but box method. So use your box method and come up with an answer. What does that mean is, now we have 10 different boxes to be filled. And every box I can fill with any number of, whatever is given out of that, all the options are there. So whenever somebody says repetition is allowed, what I do psychologically is, I had 4 A chocolates, 3 B chocolates, 2 C chocolate and 1 D chocolate. I will subconsciously replace those chocolates by boxes of that chocolate. So now I have 4 boxes of chocolate A, 3 boxes of chocolate B, 2 boxes of chocolate C and 1 box of chocolate D, and each of these boxes is more than 10 chocolates. So what I can do is, I can make this word in such a manner that all of them are D, all of them are C, all of them are B, all of them are A. If you think very carefully, when I'm trying to fill this first box, so there, because of this repetition, I have only 4 ways to fill it. Either I can write A here, B here, C here, or D here. There is no other choice. And I can have 4 boxes of A, but even 1 box of D is enough because it has more than 10 chocolates. So this 4 boxes, 3 boxes, 2 boxes is not going to make any difference. What we need to consider is how many distinct boxes of chocolate I have. So distinct boxes of chocolate are nothing but 4. So first I can fill using 4 options. Next again 4 options, and this I can do till the last one. So my answer becomes 4 is to the power 10. If you have lost this logic, please reverse this for 5 or 10 seconds and listen this once more. You will get it. Now let us move forward. If I am saying 5 letters, so what you need to do is you need to make 5 boxes. This can be filled using 4 ways. This can also be filled using 4 ways, 4 ways, 4 ways, and 4 ways. So your answer becomes nothing but 4 raised to the power 5. Now this next part is very interesting. What we are saying is we have to do combination or selection. You have been given 4A, 3B, 2C and 1D. And now what we are asking is how many 10 letter we can choose, and or 10 chocolates we can choose out of them when repetition is not allowed. When we say repetition is not allowed, that means whatever is there is fine, more we cannot do. So in how many ways can you choose those chocolates? Now see, think of this question like there are 10 chocolates placed in front of you, 4 A chocolates, 3 B chocolates, 2 C chocolate and 1 D chocolate. Paint this mental picture. They are in front of you. And if I ask you, these are the only chocolates that you have, pick any 10. So you have only 10. There is no choice. So you will have to pick all of them. So answer becomes nothing but 1. And then this kind of question has already been asked in JEE, where they confuse the students a lot. Students are writing 5 factorial, 3 factorial, and whatever they want to. But the actual answer was 1. Another thing that we can do is basically, what we are saying is 10 objects, 10 chocolates you can choose, but repetition is. So I will have to replace them by boxes of chocolates. So what does that mean is, ultimately, what I have choice is basically, despite everything is, I have only 4 distinct types of chocolates. So whatever I can do, I can choose either A chocolate, B, C or D. I can choose all 10A, all 10B, all 10C, all 10D or some kind of a variation of that in ABCD. But every time I will have either A chocolate, B, C or D. So again, we can write A plus B plus C plus D is equal to 10. And now we can apply our beggars method. So what beggars method says is write 10 here. A, B, C, D are 4 objects plus 4 minus 1 C10. This becomes our answer. If I want to do it for 5, then I will write A plus B plus C plus D is equal to 5. So my answer becomes 5 plus 4 minus 1 C5. Very simple. If you understand beggars method, this is not a difficult problem. Now let us come on to the 6th part that says that 5 but repetition is not allowed. Now this is very interesting because when nothing will work, we will have to use method of cases. So we will use method of cases. So what I can do is basically, I can say that, see, the maximum similarity that can happen is 4A. So we can start with 4 same, 1 distinct. This can happen. Another case that can happen is nothing but 3 same and then 2 same. This can also happen. Then what can happen is nothing but 3 same and 2 different. This is also possible. Then 2 same and 1 different. This is also possible. And then we can have 2 same and 3 different. This is also possible. Now all different is not possible because we have 4 chocolates. How can 5 chocolates be different? That is not possible. You can see that out of all the possible cases, we are getting these 5 relevant cases that we need to calculate, add and come up with an answer with. So if I write the answer of the first one, what I am getting from here is nothing but I have 4 same, 1 different. So now what you can see is basically 4 same can be 4 A's only. So you have 1 way to do it. 1 different you can choose from these 3. So there are 3 ways to do it. So your answer becomes 1 into 3 in this case. The next part, when you are doing, you have 3 same and 2 same. Now 3 same and 2 same. So 3 same either can be 3 or 2B. So you have 2 ways to do it. And 2 same, you can take either 2B or 2C. So there are 2 ways to do it. Because you have already selected A cannot be done again. So again, the total ways are nothing but 4 here. In the next one, there are 3 same, 2 different. So 3 same can be nothing but 3 A's we can take like A, or 3 B's we can take like B. If I take any of these cases, there are 2 ways. And then 2 different. Let us say if I have taken this, so in order to take the remaining, what we have a choice between B, C and D. So out of these 3, I can take any 2. So 3C2. And in the next one, what I am doing is 2 same, 1 different. So 2 same, 2 same, 2 same. So I have choice between A, B, C. So out of these 3, I can choose any 2. And 1 different. Let us say I have chosen these 2. So then C and D would be left. Out of that, I can choose again any one. So 2C1. And the last one, what we are doing is nothing but 2 same, 3 different. So 2 same. Again, we have 3 choices. So I can choose one out of that. And remaining 3, I will have to choose to 3C3. So these are my total number of selections that can happen. And if you again did not get it, please rewind it by 5 seconds and try and get the method. Right. See, now let us go back to the one question that we left. Let us copy all of this down, because this is going to be very useful while doing that question. So if I go into this question and answer that, if there are 5, it is same question, just we have to do arrangement. So what we will do is we'll write the same things. So we will make the same kind of cases as earlier. Only thing is now we also have to write their arrangement. So in first case, what is happening is we are getting something like A, 4 A's and 1 B. This is one of the examples. So once you have got this, you will also arrange this. So arrangement will become nothing but 5 factorial, and since 4 A's are there, by 4 factorial. Similarly, in the next case, what you will observe is there are 3 A's, and I am writing one example, and 2B, something like this. So if you arrange it, it is 5 factorial by 3 factorial into 2 factorial. And similarly, if I write the next one, and I will have to multiply by 5 factorial by 3 factorial. In the next one, I will have to multiply by 5 factorial by 2 factorial into 2 factorial into 1 factorial. And in the last one, we will have to multiply by nothing but 5 factorial by 2 factorial. Now you can understand here that all of these are complete ways in themselves to solve a problem. So what we'll have to do is we'll have to add them, add all the cases and get to the answer. And this you should generally understand is inside a case we'll multiply and cases we will add. And even if you remember this, you will be able to get most of the questions right. Now, once we have covered this basic theory, there is one more thing I can tell you, and then we will move on to the problems. So now one more thing can happen is total number of selections that are possible. So now what we are saying is if we have A, B, C, D, E, whatever number you are choosing, that is not important. How many such selections are possible? So you can say that, sir, I can have 0 selections. I can make 1, 2, 3, 4 or 5. So if I make 0 selections, the answer are 5C0, then 5C1, 5C2, so on and so forth till 5C5. Now each of them is a valid selection, so we are going to add it and get to the answer. So this is one way to think. Another way is basically, so this is you are thinking as a person who's trying to make those selections. So you are the subject and the things that you are selecting is the object. But if I think from an object's point of view, from A's point of view, then what will happen? So if I think like an A, then what can happen? It will be either selected or not selected. B will be selected or not selected. So every one of them has 2 choices. So answer, if I see from here, is 2 raised to the power 5. And we know from binomial that both of them are going to be equal. Why am I telling you this? Sometimes in assertion reasoning question, they will make this as 2 options and they will want you to compare both of these approaches. Now, if I slightly change the question and say that we have all identical A's, then again we can have 0 A's, 1, 2, like this we can have 5. But this can also be done in one way, so on and so forth, one way. So you can see that the total number of choices that we have is 5 plus 1. And in this, when we are mixing the objects, now what we can do is first we can choose A, then B. So you can see that you are making a pipeline. And since you are making this sequential logic, will multiply. So corresponding to A, since there are 4 A's, we just saw that if there are 5 A's, there are 5 plus 1 ways. So if you have 4 A's, the answer is going to be nothing but 4 plus 1. Similarly, for the next part, it is going to be 3 plus 1. For the next part, again 2 plus 1. And for the last part, nothing but 1 plus 1. And if we multiply it, we get our answer. So what we can conclude here, let us write that conclusion in very short. So what we are saying is if we have n distinct objects, the total number of selections are nothing but 2 raised to the power n. If we have n identical objects, then it is nothing but n plus 1. And if you have mixture, and a mixture of n1 objects, n2 objects, and such kind of a mixture is there, then the answer is n1 plus 1 into n2 plus 1 into n3 plus 1, so on and so forth. Like this, you can apply this concept and get to the answer. So what we have done is by using this 24 variations, we have covered all the techniques there are in the chapter. We have also covered the context of those techniques, what can be applied where and what cannot be applied where. And now we will see what kind of questions JEE has asked in 13 problem types. and see how these techniques can be applied in all of those category of problems, and we can arrive at answers. If I look into this first type of problem, it is based on the idea of NPR and NCR. So what happens in such kind of problem is you have to directly apply the formula of NPR. Now NPR is nothing but n factorial by n minus r factorial, and NCR is nothing but n factorial by n minus r factorial into r factorial. So there are two steps in such kind of questions. First, you apply this formula, then you do simplifications based on factorial notation, and you get your answer. Now let us see a question that was asked in 2023 on this idea. So in this 2023 question, they have given ratios of two NPRs, and they want us to tell the value of this expression. So again, we have two steps here. First step would be to find this ratio. So if you write 2n plus 1 p n minus 1, it is n factorial by 2n plus 1 minus n plus 1 factorial. And then if you divide this by 2n minus 1 pn, it becomes 2n minus 1 factorial by 2n minus 1 minus n factorial is equal to 11 by 21. And now if I simplify this, this can be written as 2n plus 1 factorial by 2n minus 1 factorial and n minus 1 factorial by n plus 2 factorial is equal to 11 by 21. See, now here what you can do is a very simple simplification based on factorial notations. Now let us look into that. Then the step 2, this 2n plus 1 can be written as 2n plus 1, 2n into 2n minus 1 factorial divided by 2n minus 1 factorial, and the denominator part, that is n plus 2 factorial, can be written as n plus 2, n plus 1 into n into n minus 1 factorial, and that is 11 by 21. Once you have written in this manner, now you can see that this part, that is 2n minus 1 factorial, and n minus 1 factorial would get cancelled, and what is left is 2n plus 1 into 2n by n into n plus 1 into n plus 2 is 11 by 21, and now this n will get cancelled out. So what we are getting in numerator is 4n plus 2, and denominator n square plus 3n plus 2 is equal to 11 by 21. Now we need to simplify this. If I simplify, this becomes nothing but 84n plus 42 is equal to 11n square plus 33n plus 22. If I simplify this, I get a quadratic equation, that is 11x square minus 51n minus 20 is equal to 0. And if you solve this equation, you get the value of n as nothing but 5. You will have to solve it as vicious calculation, but there is no way around it. So once you have done this, next step is very simple. Now in the last step, they want us to find the value of n square plus n plus 15. So if I want to find the value of n square plus n plus 15 in the third step, it is going to be nothing but 25 plus 5 plus 15, that comes out to be 45. And that is nothing but our answer. So it involves a lot of calculation, but actually it is a simple kind of application involving NPR and NCR. Now if I look into this next 2024 question, this question talks about two relationships, one in terms of C, an inequality, and another in terms of P. So let us figure out the value of m and n using these two relations. So if I look into the first one, what I can do is I can write this as 6cm plus 6cm plus 1 plus 6cm plus 1 plus 6cm plus 2. And on the right hand side, we have 8c3. So right hand side might not be very useful in the first two steps. But now once you have this property that NCR plus NCR minus 1 will be equal to n plus 1 CR. So what is happening is, the one with the smaller one, in this we are adding 1 in the above as well as below. So in this, the smaller one is this, we will add 1 here in the above and 1 below. Similarly, we will do in the other part. You can see that now the smaller one out of this is this one. We will do the same thing, and this will become 7cm plus 2. this is greater than 8C3. Once you have done that, you can see that again similar kind of relation is getting formed, and again this is the smaller one, so we will do the same thing. So this will become 8Cm plus 2 is greater than NC3. You can see that the maximum value of NCR in this case for 8C3 will come at 4. So if it needs to be greater than 8C3, M plus 2 needs to be equal to 4. Only then the maximum value will come. So you can clearly see that here the value of M comes out to be 2. This is the first part of the question. If I move towards the next part of the question, what they're saying in the next part is you have this relation n minus 1 P3. N minus 1 P3 can be written as n minus 1 factorial by n minus 4 factorial. On the other hand, the NP4 can be written as n factorial by n minus 4 factorial. You can see that this will get cancelled out. If this cancels out, we will get n, and they have given the value equal to 1 by 8. So value of n from here comes out to be nothing but equal to 8. Once you have got the value of m and n, the third step is very simple. What we need to do is we need to substitute the value in the third step. So let us put it. So it will become 8p m plus 2, that will become 3 m plus 1, and then you have another one in c, so this will become 9c2. We need to calculate this value. So once we figure out this value, this becomes 8 factorial by 5 factorial. This becomes 9 factorial by 2 factorial into 7 factorial. This will cancel out and will become 8 into 7 into 6. This will cancel out and become 9 into 8. And if I divide by 2, this will become 4. Now you can see that if I am looking into this question, if I simplify this, this comes out to be 372. And hence option C matches. This very interesting 2024 question it talks about alpha and beta. And in alpha, you can see that what they have written. Let us understand this first part. They have written 4 factorial ka factorial, so that will become 24 factorial because 4 factorial is 24. And divide by 24 raised to the power 3 factorial, that will become 6. If I do some prime factorization, what you will understand is this is 24 factorial. In the denominator, what we have is nothing but 2 cube into 3. That will become 24 raised to the power 6. So what we have written in the denominator is 24 factorial divided by 2 raised to the power 18 and 3 raised to the power 6. So what we need to check here is basically in this 24 factorial, what is the highest power of 2 that would be present? If it is more than 18, then of course it will get divided by 2 raised to the power 18. Similarly, we will do for 3 and check whether the power of 3 in 24 factorial is it greater than 6 or not. Now, in order to do this, we have a method of factorial notation. So if I want to find the powers of 2, I will take 24 divide by 2, put a greatest integer function. Then 24 divided by 2 square, greatest integer function. 24 raised to the power 2 cube, greatest integer function. Then 24 raised to the power 2 raised to the power 4, greatest integer function. After that, it will become 0. So this one, the first one, we can clearly see that this will become nothing but 12. This will become 6. And you can already see that we have already got 6 and more terms will come. So for 2 raised to the power 18, the condition is getting satisfied. We do not need to worry about it. Let us also check it for 3. So if I check it for 3, let us say what happens. We will take 24 divided by 3, put a greatest integer function. 24 divided by 3 square, greatest integer function, so on and so forth. In the first part only what you are getting is 3, 8. You will get 8 from here directly. So rest of the terms do not matter. The power is going to be greater than 8 only. So this will also get divided. So we can notice that when you divide this, the number that is going to come out is going to be a natural number. Like we have done this first part, I can also implement the second part for beta. In the second part for beta, we can write this as nothing but 120 factorial by 120 raised to the power 24. And now 120 factorial is fine. In the denominator, 120 can be written as nothing but 120 can be written as 12 into 10. So this will become 2 cube into 4 into 3 So 2 raised to the power, let us correct it. 12 can be written as 4 into 3 into 2 into 5. So this will become 2 raised to the power 3 into 3 raised to the power 1 in 5 raised to the power 1. And if I put 24 power, this will become 2 raised to the power 72, 3 raised to the power 24 and 5 raised to the power 24. See, now what we need to check here is only power for 5 and 2, because if it is 2 for 5, automatically it will be 2 for 3, because in 120 factorial, the number of powers of 5 will be more than number of powers of 3. And hence, now if you look into this question, what is going to happen? For checking this, we will take 120. And let us first check for 2. So if I divide by 2, then 120 divided by 2 square, 120 divided by 2 cube, so on and so forth. In 1 or 2 terms, you will realize that this became 60. We have already crossed 70, 90. So 72 we have already crossed. So for this, the first one, the condition is true. Similarly, we can do it for 5. So 120 divided by 5. You are already getting 24, and then after more terms will come. So again, this condition will also get satisfied. So this is also fine and this is fine. This will automatically fine. We can see that if I simplify, this will also become a natural number. Hence, we can clearly say that option A is going to be correct.
Now, next problem type is nothing but problems based on principle of counting or box method. Same way of saying both the things, but box method somehow appeals more because it is a problem solving method. So let us look into this question that was asked in 1998. This question talks about number of divisors of the form 4n plus 2, where n is greater than or equal to 0. So if you simplify this, what they want us to ask is 2 times 2n plus 1, matlab 2 into an odd number. How many such kind of divisors would be there for 240? Now this is a very simple question, because if you factorize this, it is 2 into 2 into 2 into 2 into 3 into 5. You simplify, what we are getting is 2 raised to the power 16, 2 raised to the power 4 into 3 into 5. So now if you think about number of factors that are of this form, so one of such factors we can write is 2 into 3. We have taken 2 from here and 3 from here. Another such factor can be 2 into 5. Another such answer can be nothing but 2 itself, because they are putting the value of n greater than or equal to 0. And one could be, if I take this 3 and 5 together, still it is an odd number, so 2 into 15. So we can observe here there are 4 such possibilities, hence A option comes out to be correct. Now let us look into this next question that came in 2019. In this question, what they are saying is, and it looks like a question of geometry, but it is not. So if you carefully write it down, what they are saying is, set of all the triangles in the xy plane. So let us draw xy plane such that each having one vertex at origin. So one vertex is here at origin, and the other two vertices lie on the coordinate axis. So let us say that if one is here, A, then another would be here, and 4 such cases would be possible. One could be here also and here also. So I am taking 1 cases, but whatever answer I will get here, I will multiply that by 4 to get my relevant answer. So this we have figured out. Now what they are saying is, this number needs to be integral also. So this can be placed at 1, 2, 3, 4, something like that. What they are saying, each triangle has area 50 square unit. So now if I write this as x and this as y, then what we are saying is half of x into y should be equal to 50. So xy is equal to nothing but 100. So now question talks about that how many such values of x and y are possible such that this area comes out to be 100. So we'll write the answer for first quadrant, and then you'll multiply it by 4. So now how many such values are possible? So this depends upon number of ways in which we can factorize this 100 and such pairs of numbers that we can write. So if I try and write all the divisors, so what is the technique of finding all the divisors? So we can write this as 2 square into 5 square. So if you try and write all the divisors, what will happen? So for a divisor, what need to happen is, in the power of 2 there is a box, in the power of 5 there is a box. So this box we can fill using 0, 1, 2, and this box also we can fill using 0, 1, 2. So all the divisors are this form, and this box can be filled in 3 ways. So answer becomes 3 into 3.
that is nothing but 9. This is what we are getting. So there are 9 such divisors in which way this can happen. So now what can happen is, let us take an example. So if I take one of these values as, let us say 2, then ultimately another value will become 50. And see, this is x coordinate, this is y coordinate. So if we write 50 into 2, this will also counted as a valid answer. So what we need to find is two such numbers. So again, what we want is two such numbers whose multiplication is equal to 100. So now see, you have only freedom to fill this box. So if I, for example, if I fill this box by 2, this automatically becomes 50. So once you fill this box, this automatically becomes fixed. So now how many ways you can fill this box will be equal to nothing but number of divisors that we have. So this is nothing but number of divisor. Hence the answer of this question becomes 9. But since this is the answer only in first quadrant, the answer in all the quadrants that are possible would be 4 into 9, that is 36. Hence A option becomes correct. Now this question is again a very simple question based on prime factorization. So again, if I take this number n, what they're writing is there is an x, y, z in the power. So their prime factorization they have given. Now what they want is number of odd divisors. See, whenever the number of divisors need to be odd, so let us go back to the same concept that we did earlier. So if I'm writing any factor, it will have 2, 3 and 5, and in this box we can fill values. So when they are saying it needs to be odd, this value that we are filling here needs to be 0. Otherwise it will become an even number. It will have a factor of 2. Now what we have is this value that we need to fill here and here. So now if this value is y, what we can fill here is nothing but 0, 1, 2 up till y. And this value that we can fill is nothing but 0, 1, 2 up till z. And hence corresponding to this there are y plus 1 values possible. Corresponding to this box there are z plus 1 values possible. So we can multiply and get the answer. So this is what the first part of the question talks about. Now the problem is that we do not know the value of y and z. In order to find that value, they have given another 2 conditions to us. So let us find those values using second conditions. So if I write y plus z is equal to 5, the other equation can be written as 1 by y plus 1 by z. It will be equal to 5 by 6. And if I simplify this, this is nothing but y plus z by yz is equal to 5 by 6. And y plus z is nothing but 5. So 5 by yz is equal to 5 by 6. So from here we can see that y into z comes out to be 6. See, now there is no need to solve because JEE questions are framed very intelligently. So they have given this value as 6 and y plus z is given as nothing but 5. So you can guess the values of y and z because both of them are natural numbers. And they have also given that y is greater than z. So now we can guess the value. The possible values are nothing but 3 and 2. You can also solve, but guessing will make your life really simple. Once you have got this value, you can put in the third step in this and get the answer. So our answer becomes nothing but 3 plus 1 into 2 plus 1. And that becomes nothing but 4 into 3, 12. So option 3 becomes correct. Now in this question, what they're saying is they are asking us to consider 3 boxes. And each box has ball which is numbered 1 to 10. This is the first statement in the question. Suppose now one ball is drawn randomly from each of the boxes and I denote the label of the box in the ith box. So if I am taking this ball, this is nothing but n1 from box 1, this is n2 from box 2 and this is n3 from box 3. Now what they're saying is in how many ways can this be done so that the numbers on the ball, so whatever is the number on this ball is smaller than this number and smaller than this number. See, now this kind of questions can be done in 2 different ways. I will give you the shorter and more interesting way of doing this question. So what you can do is, if I take any 3 distinct balls, so how many ways can we take distinct ball? So if I take one ball from here, it can be done in 3 ways. So it is like filling 3 boxes. So 3 distinct balls can be chosen from these 3 boxes in 10 ways, then 9 ways, and then 8 ways. So these are the total ways of choosing 3 distinct balls. Now once we have got those 3 balls, it could happen that n1 can be greater than n2, n2 can be n. Different kinds of permutation and combination are possible. And to be exact, there could be 3 factorial cases because we have 3 different objects. And what they want is out of those 3 factorial cases, one case in which n3 is smaller than n3 is greater than n2 is greater than n1. So our answer can be very simply written as this by 3 factorial, and it comes out to be 120. Let me explain once more. So what I have done is basically I have taken 3 distinct balls. Now what can happen is when we are picking those balls, they can have the same number. All of them can have the same number. 2 of them can have the same number. We do not want such balls because then there will be an equal to sign between n1, n2 or n2, n3. We do not want that. What they want us is basically distinct balls. Only then this greater than relationship can satisfy. That is the reason our first step was to find these distinct balls. So that is 10 into 9 into 8. What I'm saying is basically now this 3 balls that we have found can have 6 different relationships. How? n3 can be greater than n2 can be greater than n1, and now the more number of ways we can arrange them between each other is 3 factorial. So this many relationships between them can exist. So what we want is answer corresponding to one of that relationships. So this sample space will be equally divided among these 3 factorial cases. So answer corresponding to 1 becomes 10 into 9 into 8 divided by 3 factorial. Now let us move towards third category of problems. Though it have made it a category, but it is subsumed in the principle of counting or the box method that we did earlier. But I have made it a separate category because JEE has asked so many questions on this idea. Every year there are questions on numbers, and those questions are of different variety. So I wanted to make it a different category, though it can be also considered as a subcategory of the last method. So let us start with it. My first question came in 2022. In this question, they are talking about a 3-digit number. So again, we can make 3 boxes. And what they're saying is exactly 1 digit is repeated 2 times. Okay, so there are many methods to do this question. I am going to use a method that is known as method of destruction. What does that mean is, I am going to write total number of 3 digits that are possible and subtract those numbers which have all distinct digits and all same digits. Now this is quite easy to do. That is the reason I am using this method. Other methods are also valid and can be used. If I want to find total numbers, this first box can be filled in 9 ways. This can be filled in 10 ways, and this can also be filled in 10 ways. So if I do this, what I get is 9 into 10 into 10. Now in the next part, what they are saying is, if all are distinct, now of all are distinct, what will happen is this will still be filled in 9 ways, but we have since used 1 out of 10, only 9 are left, so 9, and then again we have used 1, so next can be filled in 8 ways. So again if we multiply, it becomes 9 into 9 into 8, and then in the third part all are same. See, all can be same in only 9 ways: 1 1 1 1 1, 2 2 2 2 2, 3 3 3, 4 4 4, 9 9 9. So corresponding to third, only 9 cases are possible. If I simplify this, what I get is nothing but 243. A very simple question that was asked in 2022. Now this 2022 question talks about a 6-digit number in which we have to use all of these 1, 2, 3, 4, 5, 7, 9. And all of these needs to be there. So essentially what they want us to write is a 6-digit number that looks like this, where one of the digit is getting repeated out of this, and then all the others are present. So this is an example. So a very important thing in P&C is to visualize what is exactly happening, because most of the students will take some assumption and that assumption will not turn out fine. It is better to write few examples, understand what is happening, and then think of a process that will work out. So you can see that one of these digits will get repeated. So out of this 5, let us choose that one digit that will be repeated. Once we have got that, now you can see that we will have such kind of a scenario. Now this 6 digits can be written or arranged in the form of 6 factorial by 2 factorial, since 1 is getting repeated twice. So our answer comes out to be nothing but D option. Now in 2023 question, they are talking about a 7-digit odd number. So now there are 2 methods. One is the method of destruction, in which we will write total cases and subtract the cases in which this is not happening, or we can do this using a method of construction. Let us try both the methods and see how they work out. So if I talk about the method of destruction, what I can write is I can write the total cases and minus even numbers from it. This is much simpler to do. So total cases would be nothing but 7 factorial. Since these 3 and these 2 are repeating, so 3 factorial into 2 factorial. Now when we are making even number, what is happening here is, if I am writing a 7-digit number, in my units place, you can see a 2 needs to come. So now in this 6 places, what we need to arrange is nothing but 1 1, 2 2, 2 3s and 1 5s. So total ways of arranging this would be nothing but 6 factorial by 2 factorial into 2 factorial. And if you simplify this, this comes out to be 240. Now there could be another method as well, that is method of construction. In this next method, we will try and generate the numbers. Now in this case, you need to be very careful. You need to make cases rather than take any assumptions. So what you need to do is write all the possible cases. So one of those cases would be when in that odd number 1 comes in this place. When 1 comes in this place, so these numbers, this is my case 1. These places can now be filled using 1, 2, 2 2s, 3 2s, 3 5, 3, 2 3s and 1 5. So in this case, your answer will come out to be nothing but 6 factorial by 3 factorial into 2 factorial. One more case can happen in which this last place, we can see 5 can come. Here we were writing 1, if I write 5 here. So now this case also be same as earlier only, because again we have 2 2s, 1 1 and 2 3s to be filled here. So answer comes out to be exactly same as earlier, that is 6 factorial by 3 factorial into 2 factorial. And then there would be a third case. This third case talks about writing 3 here. Now these 6 places can be filled using 1 1, 3 2s, 1 3 and 1 5. So this becomes 6 factorial by nothing but 3 factorial. So you can see that if I want to write the total answer, what is going to be the answer in this case? In the first case, we were getting 6 factorial by 3 factorial into 2 factorial, and that is same as the second one, so I can multiply by 2, and in the last case 6 factorial by 3 factorial. And if you simplify, you can see this 2 and 2 are getting cancelled, so 2 times 6 factorial by 3 factorial, and this also comes out to be 2 factorial. You can use either of the approaches to get the answer, but the first one is shorter, that is the reason I told you that. Now this 2020 question is again a very simple question. Now what they are saying here is you need to make a 5-digit number, and they have given us a very strict instruction how to make it. So what they are saying is here in the 10th place 2 needs to come. So let us fill 2 here. And now they are saying the answer is this, find the value of k. So now you can see that the first place can be filled using 8 digits, that is except 0 and 2. So there are 8 digits. Now here we can fill 0. So again we will have 8 options. This can be filled using 7 options, and this can be filled using 6 options. So my answer is this. Now if I write 8 into 7 into 6, this is my answer. Now what they are saying is this is equal to 336k. So k is nothing but 8 into 7 into 6 divided by 336. And if you simplify this, this comes out to be 8. If I talk about this 2023 question, it talks about the digits of this number. So you can write this digit as even and odd numbers. So there is 1, then another odd number would be 3, then again 1, then again 3, then again 1. So these are the odd numbers involved, and the even numbers are nothing but 2, 4, 2, 4. Now what they are saying is if we write a 9-digit number like this, even number should come at even places. So in these places, those are my even places, I can only fill even numbers. So let us fill these numbers in these even places. So 4 numbers can be filled in 4 places by 4 factorial by 2 factorial into 2 factorial, because there are 2 digits identical here. If I fill the remaining ones in the odd places, so now for that one, what you will get is 5 factorial, and 3 of these are identical, so 3 factorial into 2 factorial. If you simplify this, you should get your answer, and your answer, if you do, comes out to be nothing but 60. Now this is a very interesting question that came in 2019. Interesting not because the question is tough, but how fast we can solve. That is a competition that we can do in this question. So now the question says that if you make a number that is smaller than 7,000, that is we want to write using this digit, and repetition of digit is allowed. Now this is very important. So 3 things are important that are given in the question. So see, now there is a traditional way of doing this question. So traditional way of doing this question is, first we'll write all the 4-digit numbers. In the second part, we should write the all relevant 3-digit numbers. Then in the third part, we should write all the 2-digit numbers. And in the fourth part, we should write all the single-digit numbers that are relevant. Sum them up, and then come up with an answer. Now I will shortcut this process. How am I going to shortcut this process? So what we can do is, now if I want to write a number less than 7,000 using these digits, so in this place what I cannot fill is, I cannot fill 7 or 9. But if I fill 0, 1 and 3, what flexibility do I have is, basically when I fill 0 it will become a 3-digit number, and then if 0 comes in the second place also, then again it becomes a 2-digit number. So all the numbers I am counting at the same time. So what I've done is I've allowed 0 to be filled here. So there are 3 options corresponding to this. Now since repetition of digit is allowed, this can again be filled using 5 options. So corresponding to this, let us write 5, and corresponding to this again also let us write 5, corresponding to this again let us write 5. So what am I getting is nothing but 125 into 3, and if you write that up, this is 375. Now you can see that this is there in the option, but this is not the correct answer. Why? Because they are asking us to write natural numbers. When I do it in this manner, I will be able to write one number where 0, 0, 0 and 0 will come. Now this is not a natural number, this is a whole number. So we need to subtract this 1 from it. So 375 minus 1, 374 will give me my right answer. Now in this 2023 question, again a very simple question has been asked. Again we can use our box method. So what we need to do is, we need to find a 4-digit number that is greater than 5,000. Smaller than 10,000 would mean a number that is 4-digit number. So now here when we want to write this number, and they have also given us the digit, but here they have mentioned without repetition. So you can see that, understand those problem variations that we talked about earlier, they are now coming into picture. Repetition happening and not happening will change the way how we are approaching it. So now what you can do is, this first box, now here what we can fill is nothing but 5, 7 and 9. So this can be filled in 3 ways. The next one now can be filled using 4 ways. The next one can be filled using 3 ways, and this can be filled using 2 ways. So 3 into 4 into 3 into 2 comes out to be nothing but 72. That is nothing but option C. Now this is a divisibility based question. In such questions, we will have to use the divisibility property of numbers. So now when they are saying the number needs to be divisible by 6, that would mean it needs to be divisible by 2 and 3 simultaneously. Now the divisibility of 2 is the last digit. So if you are writing a 3-digit number, this would mean this 3rd digit needs to be an even number. If it is even, it will be divisible by 2. So this is one thing. And if I take this numbers as x, y and z, for being divisible by 3, then x plus y plus z needs to be a multiple of 3. So we'll have to use both of these conditions simultaneously. This is the first part. If I try and do that, you can see that the possible values of z can be only 2, because we need to make number using this and repetition is allowed. So z can be 2 or 4. These are the only 2 possible cases. Now if I take z is equal to 2, in that case what should happen is, then x plus y plus 2 needs to be a multiple of 3. So an important question to answer in this scenario is how to make those cases. So there is an efficient technique. So now what I can take is, I can take both the numbers at 1. So 1, 1, 1, 2, 1, 3, 1, 4 and 1, 5 till here we can go. So this we are choosing numbers and then we will arrange. So then what we can do is, we can start with 2. So 2, 2, 2, 3, 2, 4 and 2, 5. Next what we can do is, we can move towards 3. So 3, 3, 3, 4 and 3, 5 and ultimately 4. So 4, 4 and 4, 5. And we can end this by writing 5, 5. So these are the all possibilities that we can have for x and y both. So if I try and write the numbers, what is going to happen is, the first is, if I take 1, 3 and 2. So 3 plus 1 is 4, 4 plus 2 is nothing but 6. This is going to satisfy. Then if I take another as nothing but 2, 2, then 2 plus 2 is 4, 4 plus 2 is 6, again it will satisfy. 2 plus 5 is 7, plus 2 is 9, it will never satisfy. 2 plus 5 is 7, plus 2 is 9, this will also satisfy. 3 plus 3 is 6, 6 plus 2 is 8, will not satisfy, but 3, 4, that is 7, 7 plus 2 would be 9, will satisfy. Then next, if I take 4 plus 4 is 8, 8 plus 2 would be nothing but 10, will not satisfy. 9 plus 2 will be 11, will not satisfy. 5 plus 5 is 10 plus 2, this will satisfy. So these are the possible cases that can happen. Now this is for the first one. If I take another part, that is if I take the value of z is nothing but 4. In that scenario, what should happen is, now x plus y plus 4 should be a multiple of 3. So again, let us see out of these cases which one satisfy in this case. So in this case, what is going to happen is, if I take 1 plus 1, it is 2. 2 plus 4 would be 6. This is fine. Then 1 plus 3 is 4. And 4 plus 4 is 8. No, but 5 plus 4 will become 9. And then let us take 2 plus 2, 4. 4 plus 4, 8. Again, not, but 2 plus 3 is 5. And 5 plus 4 will become 9. It will satisfy. Then 5 plus 2 is 7. 7 plus 4 is 11. No, but 6 plus 4 will become 10. Again, no. 4 plus 3 is 7. 7 plus 4 is 11. No, but 3 plus 5 is nothing but 8. 8 plus 4 is 12. This will satisfy. Then if I start with 4 comma 4, 4 plus 4 is 8, 8 plus 4, 12. This will satisfy. Now let us try and write the cases that are getting satisfied in the first one. And this is the third part of my answer. So if I fix here 2, what can be the first two values? So based on what we saw, it can be 1 comma 3. Then 3 plus 1 is 4, it gets satisfied. And now you can arrange them. See, 2 is fixed, but 1 and 3 we can switch places, and this can be arranged in two ways. So answer that we are getting is 2. Then the next is nothing but 2 comma 2 and 2. This can be arranged in one way. And then what we have is 2, 5, 7 plus 2, 9. This again we can do in two ways. Then again what we have is nothing but 3, 4, 2. Again two ways. And then 5, 5, 2. This can be done in nothing but one way. Let us do the same kind of activity for the other one. So the answer for the first case that we are getting is 2 we are getting nothing but 3 times. So 6 plus 2, 8. So what we are totally getting for the first one is nothing but 8. If I move to the second part, what can be the possible scenarios? So what we can have is 1, 1 and 4. 4 is fixed. So again you can arrange in only one way. The next will become 1, 4 and 4. Again you can arrange in two ways. Then 2, 3, 4. Again you can arrange in two ways. And then 3, 5, 4. Again you can arrange in two ways. And then 4 comma 4. And then 4. This you can arrange in one way. If we sum this up, this is also 6 plus 2, 8. And so 8 we are getting from the first one, 8 we are getting from the second one. So 8 plus 8 becomes nothing but 16, which is nothing but our answer. Now let us look into this next question that was asked in 2023. What they're saying is, using 1, 2, 3, 4, 5, we need to make 3-digit numbers divisible by 3, and repetition of digit is allowed. And all the three conditions we have read very carefully. So we want 3-digit numbers like this. And what should happen is, this needs to be divisible by 3. So if I write this as x, y and z, then x plus y plus z needs to be a multiple of 3, another condition. And then the third part is, which can be formed using this, and repetition is allowed. So I can use 1 many times, 3 many times, 5 many times, 8 many times. So there are two approaches. Let us do using both the approaches. So if I use my approach 1, it is smaller. What I can say is, see, since the repetition is allowed, all 3 digits can be same. So now we are making cases, so all same. So now if I take all the digits same, what can happen is 1 plus 1 plus 1 can happen, or 3 plus 3 plus 3 can happen. So what will happen is, whatever way you do it, since the same digit is getting added 3 times, it will always be a multiple of 3. So now this can happen in 4 ways. We can go till 8 plus 8 plus 8, and all of these will be multiple of 3. So we have got 4 as our answer for the first case. Another case that we can do is when we have 2 same and 1 different. 2 same and 1 different. Now how does this 2 same 1 different works out? So now what you can do is, you can take 2 ones, or you can take 2 3s, or we can take 2 5s, or we can take 2 8. If I do this, so 1 plus 1. Now here, along with this, if I take 3, 5 and 8, so this is 2. If I add 3, it becomes 5. If I add 5 plus 2, 7, and 8 plus 2, 10. So none of these cases getting satisfied. So corresponding to this, there is no solution. If I take the next case, with this I can use 1, 5 and 8. So 3 plus 3, 6 plus 1, 7. This will not work out. 3 plus 3, 6, 6 plus 5 is 11. This will not work out. 3 plus 3, 6, 6 plus 8 is 14. This will also not work out. If I move on to the next part, what I have got is nothing but 1, 3 and 8. So if I take 5 plus 5, It will be 10 plus 1, 11, will not work out. 5 plus 5 is 10. 10 plus 3 is 13, will not work out. 5 plus 5 is 10 plus 8, 18. This will work out. So what will work out is this case. And these two are not working out. So we have got one more area. And then 8 plus 8 now is 16. So again we can take 1, 3 and 5 correspond. So 8 plus 8 is 16 plus 1, 17. Will not work out. 8 plus 8 is 16 plus 3, 19. Not work out. 8 plus 8 is 16 plus 5, 21 will work out. So corresponding to this, we have got two cases. And see, if I arrange these, I will get 3 cases corresponding to that. And if I arrange this again, I will get 3 answers corresponding to that. So from here also, I am getting 6 answers. This we have done. Now we can move to the third part. In the third part, what we can say is all different. All of them are different or distinct. How can we do it in this case? So if I do it in this case, what we can write is nothing but 1. So how to make these cases? So we can write it in ascending order. This is a very simple way of making cases. So 1, 3, 5, then 1, 3, 8. Then next you can take 1, 5, 8. Now change the digit. So what you can do is, then what we can take is we can start with 3. So 3, 5 and 8. Nothing else is possible. So if I take these 4 cases, what is going to happen here is 5 plus 3 is 8 and 8 plus 1 is 9. So this is getting satisfied. 5 plus 3, 8 plus 3 is 11. 11 plus 1 is 12. This is also getting satisfied. And 5 plus 8 is nothing but 13 plus 1, 14, not getting satisfied. 5 plus 8 is again 13 plus 3, 16. This, so 16, sorry, not getting satisfied. So you can see that if I arrange this, I will get 6 cases corresponding to this, again 6 cases corresponding to this. So if I add everything, what I have is 4 plus 6 plus 6 plus 6, that comes out to be nothing but 22. So this 2023 question, let us understand what they are trying to say. They want us to make a 4-digit number and this needs to be divisible by 15. What would that mean? This needs to be divisible by 3 and 5 both. Now, if for the divisibility of 5 is the last digit needs to be multiple of 5. So here we need to put 5 only because we need to choose a number out of this 1, 2, 3, 4, 5. And the repetition of digit is allowed. Again, we can repeat 5, but the last digit needs to be 5. Otherwise, it will not be a multiple of 15 or 5. And also, all of these should add up to. So if I take this as x, y and z, then what I'm saying for the second condition is x plus y plus z plus 5. This needs to be a multiple of 3. This is what our question is. Now how to solve it? There are 2 approaches. One, like we solved the earlier question by taking cases. So case 1 can be x, y, z are all same. Okay. Then you can have case 2 in which we can say that 2 same and 1 different. And then we can make a case 3 saying that all are distinct. I have already worked out this method or approach in the earlier question. Here I am going to take a slightly different approach, slightly longer, but you should know multiple approaches. So here I will try and write all the cases and then check which one of them satisfies. So how we are going to do it is, let us start writing the cases. So see, 5 is already fixed in the 4th place. So let us write 5 there. And first 3 places, what I can start with 1, 1 and 1 since repetition is allowed. And keep writing numbers in ascending order. So 1, 1, next would be 2. Then 1, 1, 3 can come. Then 1, 1, 5 can come. And this 5 is there in all the cases. Then next one, what we can write is, now here let us increase it. So 2 will come. Then 2, 3 will come. Then 1, 2, 5 will come. Once we have reached there, now let us move forward. So now what you can do is, next we have saturated 2 also. So we can start with 3. So 1, 3, 3 and 5 is already fixed here. Next we can write 1, 3, 5. Now let us start with 5. So 1, 5, 5. Till here we need to stop. Next what we can do is, again in place of first digit, let us start writing 2. So 2, 2 and 2 and then 5. This is one case. Then we can write 2, 2, 3. Then 2, 3, 3, then 2, 3, 5 in a very systematic order so that we do not miss on 2 places. And this is same in the last place. Let us write more cases and that will become nothing but 2. Since we have exhausted 3 enough, let us start with 5, 5, 5, 5. Now let us start with 3. So 3, 3, 3 and then 5. And then we can write 3, 3, 5 and then again write 3, 5, 5. And then again we have exhausted 3 also. Let us start with 5. So we can go till 5, 5, 5. And the last date is 5 only. So these are the total cases. We have written all the cases that are possible. And since there are not many cases, so this approach will also largely work in most of the cases. Now let us see here. So what we are saying is sum of all of them should be a multiple of 3. So 5 plus 3 is 8. So this is not the answer. But next is 5 plus 4. That comes out to be 9. So this is acceptable. Next one will become 5 plus 3, 8 plus 2, 10. 5 plus 5, 10 plus 2, 12. This is also fine. And then the next is nothing but, let me write 5 here so there is clarity. So 5 plus 4, 9 plus 1, 10. 5 plus 3, 8 plus 2, 10, 11. 5 plus 5, 10 plus 2, 12 plus 1, 13. Again not acceptable. Here also write 5. And then see, next is 1, 3, 3, 5. So 5 plus 6 is 11 plus 1, 12. So this one is acceptable. We can take this up. The next one is nothing but 5 plus 5, 10, 10 plus 4, 14. Then 15 plus 1, 16. Then 5 plus 6, 11. Then 5 plus 4, 9. 9 plus 3, 12. This is possible. Then 5 plus 5, 10. 10 plus 4 is 14. Again not possible. 5 plus 6 is 11. 11 plus 2, 13. Not possible. 5 plus 5, 10. 10 plus 5, 15. This is fine. And then the next one is 15 plus 2, 17. And the next one is nothing but 3 plus 3, 9, 9 plus 5, 14, again not possible. 5 plus 5, 10, 10 plus 6, 16, not possible. 15 plus 3, 18, this is possible. And 5 plus 5 plus 5 plus 5 is 20, again not possible. So you can see that these many cases that I have highlighted are possible. And if I arrange this, I will get my answer. So now what I can arrange is the first 3 digits. So this I can arrange, the last part I cannot arrange. So let us do that. So if I start doing that, the answer corresponding to 1 would be nothing but 3. The answer corresponding to next one will again be 3 because 2 are getting repeated. Here also becomes 3. Corresponding to this, you can see again we get is 3. Corresponding to this is see again 5, 3, 5. All are different. So we will get 6 answers. 3 factorial. And again here we will get 3. So let us sum it up. So what we are getting is 3, 1, 2, 3, 4, 5 times. So 3 into 5 plus 6. That comes out to be nothing but 21. That is the answer to this question. So this is also an approach to solve the similar kind of questions. Now let us look into this next question that was asked in 2019. This question talks about divisibility by 11. Now this is very interesting because most of the students will not remember what was the divisibility of 11. So what they're talking about is a 6-digit number. Let me write it down. So we have x1, x2, x3, x4, x5 and x6. Let us say that this is a 6-digit number. So what does divisibility of 11 says is the sum of the numbers at the odd places like x1 and x3 plus x5. If I take a difference of this with the numbers at the sum of the numbers at the even places, this difference should be a multiple of 11. This is what it says. So now in such kind of question, what you will have to do is first understand what kind of factors of 11 we are looking out here. So if you want to take the maximum that can happen, so if I consider the value of x1, x3 and x5 as 5, 7, 9. So what you can understand here is if I add this and then subtract the least of the numbers available here, that is 0, 1 and 2. Let us see what is the difference. In this scenario, 5 plus 7 is nothing but 12. So this becomes nothing but 21. And if you subtract thing, it becomes 19. So what we can observe here is, see, this can have a value between 0 to 11. So there are 2 cases possible. One, this value of n can become 0. And another thing is the value of n can be equal to 1. So we are looking into 2 values. So let us take these 2 cases. If I take n is equal to 0, in that case, what we are looking is x1 plus x3 plus x5. And if I subtract this from x2 plus x4 plus x6, their difference should be equal to 0. So that would mean x1 plus x3 plus x5 should be equal to x2 plus x4 plus x6. Now see, question clearly says that we have to make this number using this 1, 2, 5, 7, 9. So now if I try and make pair, so let us keep this 0 and 9, 0, 7 and 5 in one group. And another group I can consider is 9, 2 and 1. If I consider this group, you can see that 0, plus 7 plus 5 is nothing but equal to 12. And 9, 2 and 1 again will be equal to 12. So now you can see that both of them can take either of the values. So we have two cases here. In the first case, let us say this x1, x1, x3 and x5 are taking values from this 0, 7 and 5. And correspondingly my x2 and x2, x4 and x6 are nothing but equal to 9, 2 and 1. If this happens, see, corresponding to this, let us say how many cases would be. Now your first digit, that is x1, cannot be 0. So this can be arranged in nothing but 2 into 2 ways, that is 4 ways. And the second part that we are writing here, if I arrange this, the possible scenarios then can be nothing but 3 factorial. So that is nothing but equal to 6. So this case will happen in nothing but 4 into 6 ways, that is nothing but 24. This is what we are getting for the first part. Now we can also exchange the values. So if I exchange the values, in that case, what we will have is x1, x2, x3 and x5. Now this part can take the values as 9, 2 and 1. So this can happen in 3 factorial ways. And then the other part, that is nothing but x2, x4 and x6. And this can happen in 0, 7 and 5. If this happens, then now you can also give this 3 factorial values, because x2, second, fourth and sixth place can be 0. There is no problem with that. So you can see that the total cases corresponding to this next part would be nothing but 6 into 6, that is 36. Okay, now this is the first part. So for n is equal to 0, what is the final answer that we are getting? So in the first case, the answer can be 24. In the second case, the answer would be 36. So for corresponding to first case, the answer is 60. Now let us take another scenario. So this is my first case. Now let us move on to the second part. In this second part, what we can do is basically, now you can consider the value of n is 1. So what we are looking is the difference can be in such a manner that x2, x4 and x6 can be in such a manner that it becomes equal to 11. Now you can do some hit and trial and you will figure out that no case will satisfy this scenario. So we'll get no answer from this one. So our answer to this question becomes 60. That is nothing but option A. Now this second question is based on the idea of cyclicity. In this next question, what we are going to understand first is, see, what will be the impact on the last digit when you raise 3 to some power. So if I raise 3 to the power 1, the last digit is 3. If you raise 3 to the power 2, then the last digit is nothing but 9. If you raise it to power 3, the last digit would be 7. And if you raise it to the power 4, the last digit would be nothing but 1. And after this, you can see that the same pattern will keep on repeating. So this is known as cyclicity of numbers. Now, if I do the same thing for 7, 7 raised to the power 1 comes out to be 7. 7 raised to the power 2 will come out to be 49. So 9. 7 raised to the power 3. And again, if you multiply it by 7, will come out to be 3. And 7 raised to the power 4, the last digit will come out to be nothing but 1. So now what they're saying is, if I take this number and if I add this number, what will happen to the units place, because divisible by or multiple of 10 would mean last digit needs to be 0. So that can happen in this first case and in this third case. So whenever the number that is written, that is your n, whenever I say it is in the form of 3m plus 1, this condition will satisfy, or 3m plus 3. Their last digits will add up and become 0 and hence multiple of 10. So this is going to get satisfied. So now let us write those numbers. So first of this number of the first type would be nothing but 13. The one in the second category would be 11. Then what we are going to get in the next category is 15. And in the first one, we are going to get 17. And this will keep on moving. So what you can observe here is, if you observe this pattern of numbers, so you can observe the value as 11, then 13, then 15, then 17, and the last would be nothing but 99. You can see that this is an arithmetic progression. So if I want to find total number of terms, it is very simple. 99 can be written as a plus m minus 1 or m dash minus 1 into d. So this becomes 99 is equal to 11 plus m dash minus 1 into 2. So the value of m dash comes out to be 45. So there are going to be 45 such terms. Hence the answer of this question is 45. Now this next question is a very interesting question. It talks about the number of 3-digit numbers that are divisible by 3 or 4 but not 48. So what we want is number of elements in 3. 3 means 3-digit number divisible by 3. Union number of divisible by 4 minus number of 3-digit numbers divisible by 48. Now here we can use n of a plus n of b minus n of a intersection b. See, in mathematics, we also call this as inclusion-exclusion principle, but I always prefer to use set theory rather than using complicated principles. So now let us find all of these values, substitute and get the answer. So if I want to find n of 3, that would mean if you take 999, that is the highest 3-digit number, and divide it by 3, take greatest integer function, then take 99 and divide by 3. So what we are doing is we are counting all the 3-digit numbers which are smaller than or equal to 999, and then we are removing the 2-digit numbers, 2-digit numbers divisible by 3 from that. So what you are getting from here is nothing but 333 minus 33. It comes out to be nothing but 300. Then we can find nothing but n of 4. Again we can use the same technique, 999 divided by 4 minus 99 by 4. By this we will be able to remove the 2-digit numbers by subtracting. If I divide by 4, it comes out to be 2, and then 19, that will be 4, and then 39, so 4 into 9, 249. And if I divide by 4, it comes out to be nothing but 24. So this comes out to be nothing but 225. And the last part is nothing but n of 3 intersection 4. So 3 and 4 both would mean 3 intersection 4 would mean multiple of 3 and 4 both. That means multiple of 12. So again I can take this 999 and divide by 12 minus 99 divided by 12. And if I do this thing, so what I need to do is whatever we got earlier, this 249, if I divide by 3 more, so it comes out to be nothing but 3 into 8, 83 it will come. And the next part, if I divide by 12, it comes out to be nothing but 8. And if I simplify this, it will come out to be nothing but 75. Now, one more thing we need to find, that is n of 48. For doing that, again we will repeat the same activity, 999 number divided by 48 and take greatest integer function, 99 by 48. So if I simplify this, the first part comes out to be 20 and the second part comes out to be 2. So this becomes 18. If you put all the values in the formula above, what we are getting from here is nothing but 300 plus 225 minus 75 and minus 18. This comes out to be nothing but 432. That is nothing but option D. Now this next question is nothing but a more complicated form of the last question. So what happens is, again we have to make 3-digit numbers only, and we have to find divisible by 2 or 3 but not divisible by 7. What would this mean? Number of elements in 2 union 3 minus number of elements that are multiple of 7 and 2 would be nothing but multiple of 14. Union 7 and 3, that would be nothing but 21. So I am taking this 21 because 7 into 3, and 14 because nothing but 7 into 2. So this we need to find. So now in order to find this, we'll have to find n of 2, then n of 3 minus n of 2 intersection 3. And then we will have to subtract n of 14 plus n of 21 minus n of nothing but LCM of 7, 2 or 14 intersection 21. So now this can be further simplified and written as n of 3. Intersection of 2 and 3 would be nothing but number divisible by 6, and then number of elements divisible by 14, number of elements divisible by 21, number of elements divisible by 42, because LCM of 14 and 21 would be nothing but 42. All we need to do is find this value. Now there is a standard formula for doing so. This we can find by putting greatest integer function like this, and then for 2-digit numbers they will have to subtract that, because we only want to find the answer for this. We will write this. For 3, again 999, and this we did earlier also, divide by 3 greatest integer function, minus 99 by 3 greatest integer function. Similarly, we can find for 6 also, 999 by 6 minus 99 by 6 greatest integer function. So by doing this, we have done the first 3 parts. By finding the remaining values, again I can do the similar kind of calculation. And for finding n of 14, again we can take 999 by 14 minus 99 by 14 greatest integer function. Then again n of 21 can be written as nothing but 999 by 21 greatest integer function minus 99 by 21 greatest integer function. And ultimately n of 42 is equal to 999 by 42 greatest integer function minus 99 by 42 greatest integer function. And if you put all of these values and simplify this expression, this comes out to be nothing but 5. Now this next question goes one step ahead from the last question and talks about a 4-digit numbers whose greatest common divisor with 54 is 2. Now if I write prime factorization of 54, it can be written as nothing but 6 into 9, and that can eventually be written as 2 into 27. So what does this question means is, if I write a 4-digit number, and it should be divisible by 2, but it should not be divisible by 3. That would mean what I want to write is number of elements in 2 minus number of elements in 2 intersection 3. If I find this value, I will be able to get my answer. Now we already know that if I want to find 2 intersection 3, it means nothing but 6. And n of 2 I can find as nothing but 1, 2, 3, 4. Divide by 2. Write 999 divided by 2, apply greatest integer function. And then remove the 3-digit numbers out of this. And then similarly, we can find 6 by writing 99999 divided by 6 greatest integer function minus 999 divided by 6 greatest integer function. And if we simplify this, my answer comes out to be nothing but 3000. Now this question that was asked in 2021 improves on the idea that was asked in the earlier question. Now what they are saying is a 3-digit number whose greatest common divisor with 36 is 2. Now this is very interesting because if you write prime factorization of 36, you will get 2 into 2 into 3 into 3. So you can see that the total factors that might appear would be nothing but 2, then 4, then 3, then 9. And if I combine 2 and 3, it becomes 6. 2 and 9, it becomes 18. 4 and 3, it becomes 12. And 4 and 9, then it becomes 36. So we need to account for only those factors which have only 2. What does that mean? If I draw it in the form of a Venn diagram, this is how it looks like. So let us say that this is a set of elements of 4-digit number which have 2 as a factor. So this is the 4 wala part. And now what they are saying is, see, so if you have covered this, by default all the factors are 4 are covered. So by covering this, we have covered 12 also, 36 also. There is no problem. So if I consider 3, then we are going to get a set like this. This is a set of 3. And you can see that this set of 3 will have an intersection with this 4. And these are nothing but multiples of 12. And then we have this another part, small part. And these are nothing but multiples of 6. This is what we are talking about. So if I write it in the form of a set theory statement, so what were number of elements of 2 minus number of elements of 6 union 4. This is what we need to find. So if you do this, n of 2, we can find this will become n of 6 minus n of 4 plus n of 12. Intersection of 6 and 4 would be nothing but 12. Now what we need to do is put this value. So if I want to find n of 2, n of 2 comes out to be nothing but 999 divided by 2 minus 99 by 2. N of 6 will come out to be 999 divided by 6 minus 99 by 6 greatest integer function And then if I want to find n of 4, it is nothing but 999 by 4 greatest integer function minus 99 by 4 greatest integer function. And finally n of 12 if I want to find, it comes out to be 999 by 12 minus 99 by 12's greatest integer function. Now we can substitute all of these values. We can find these values, put it here, and the answer comes out to be nothing but 150. So this understanding through set theory, what exactly is happening, is very important for solving this question. Now this 2022 question is very interesting and quite different to other questions. What they're saying is, if you make a 4-digit number, how many digits or how many numbers can be such that so the digit at the first, second and third place is divisible by the digit at the fourth place or the last place. So now what you can do in such kind of a question is start making cases. In our first case, what you can do is we can start with the greatest number like 9. If I put 9 here, then here a number divisible by 9 can be only 9. But in this place, I can put 0 and 9 also, and here again 0 and 9 also. So you can see that the number corresponding to 9 would be nothing but 4. The similar kind of case will happen with, if I put in place of 9, 8 also. And this will also happen for 7. This will also happen for 6. And this will also happen for 5. So for all of these 4 cases, we will have again 4 cases. Now once you have observed this, our life has become easy, and let us take this as case 1 only. So you can see that in this first case, what we are getting is nothing but 20 cases. Now after this, a shift is going to happen, because now if I put 4 here, corresponding to this, I can here write 4 and 8. At the same time, this place can be filled using 0, 4, 8. So you can see that the total cases are 2 into 3 into 3. And that comes out to be nothing but 9 into 2, 18. There could be a third case when in this units place, what I can do is I can put 3. So if I put 3 here, this first place can be filled using 3, 6 and 9. And the second place 0, 3, 6, 9. So answer becomes nothing but 3 into 4 into 4. And that is nothing but 16 into 4 is nothing but 48. And then if I move towards the next case, that is the fourth case. Now what we can do is in this unit place, I can also put 2. So if I put 2 here, and in that scenario, my first place can be filled using 2, 4, 8 and 6. There are 4 scenarios. Here 0 will also get added. 2, 0, 2, 4, 6, 8. So the answer becomes nothing but 4 into 5 into 5. And you can see that that is nothing but 100. And now we are missing out on a very important case. And that important case is our fifth case, in which the units place digit becomes nothing but 1. Now it becomes 1, then here you can put any 9 digits. Here you can put any 10 digits. Here you can put any 10 digits. So the answer corresponding to that becomes 900. Now let us add it down. So first answer was nothing but 900. Another one is 100. Before 100, what we got was nothing but 48. And before that, what we got is 18. And then before that, it was 20. So if I add everything up, it comes out to be nothing but 1086. And that is nothing but the answer to this question. Now this 2023 question was extremely intelligent and interesting. In this question, they are asking us to make a 5-digit number. And in this 5-digit number, what they're saying is we need to arrange all the 5-digit numbers in such a manner that, and tell us that at what number this 42923 will come. The repetition of digit is allowed. So this is kind of a question of rank, but given in terms of numbers, and repetition is allowed. That is a very interesting point that the question maker has made. So now let us look into this, how to solve this question. If I want to solve this question, let us start with basics. So if I start with, let us say 2 here in this place, then what can happen here is in these 4 places, since repetition is allowed, I can fill this using 6 digit, 6 digit, 6 digit, 6 digit. So you can see that corresponding to this, there are 6 raised to the power 4 ways. Now you can see that until I reach 4 here, And I can also fill 3 at this place. So corresponding to 3 also, you can see that if I fill 3 here, again I can fill this 4 boxes using same 6 things. So again corresponding to this, there will be 6 raised to the power 4 ways. So we have started with 0, then 2, then 3 is covered. So now 4 will come. So 4 is fine. Then let us move on to the next step. Now you can see this next step. Now here, what we want is nothing but 2. But before 2, there is 0. So if I fill 0 here, corresponding to this, now I need to fill these 3 boxes. So there are 6 raised to the power 3 ways. And in the third step, you will see this will also match. So here you will put 2. Then this is matched. Now the next digit is nothing but that we want to match is nothing but 9. But before 9, there is 0, 2, 3, 4 and 7, 5 digits. So you can see that corresponding to everyone, let us put 0 here again to start with. Then you will have to fill 2 places, 6 square will come. And now this will happen for 0, 2, 3, 4 and 7. So 5 times this is going to happen. And after that, the next step will come where 4 will also match, 2 will also match, 9 will also match. Now let us go to the next place. Then we want to match 2, but before 2, 0 will come. And if I put 0 here, then corresponding to that, there are 6. But in the next step, if you write it down, now 4, 2, 9, and again 2 is matched. So only one place is left. Here what we can do is first we can start with 0. Then we can fill 2 here. And then we'll fill 3 here. So corresponding to this, 3 more ways will come. If I add this up, I should get my answer. So my final answer becomes 6 raised to the power 4 into 2 plus 6 cube plus 6 square will come 5 times plus 1 6 and then 3. If you add this up, you get your answer. Now if we start with this next question, in this next question, the similar kind of question as earlier as asked. It is only that now we are making 5 digit numbers using digit 1, 2, 3, 4, 5, 7. Repetition is allowed still, but we are writing it in descending order. This is very important. So what they are asking is, what is the serial number of this? So now what we will start is, when we are starting making this 5 digit number, so what we need to take care is the descending order. That is a very important thing. So I need to start with 7 here. And then you can see that the next iteration that will happen will have 5 here. And we need to reach 3. So after 3, we can stop. Now this can be done since repetition is allowed and we have 5 digits. So 5 raised to the power 4. This can be done in 5 raised to the power 4. Now here again we'll start in the ascending order. So 7 we will put. And after we need to reach 5, then there are 3 places to be filled. So 5 raised to the power 3. Then next what we can do is we can put 5 here, but then 5 matches. In the next place, now you can put 7 here. Again 2 places to be filled, so 5 square. And again 3, 5. And then again after 5, 7, 5 will come. And you can see the next, again we can fill in 5 square. And then we can move on, keep on doing this. So 3, 5 was there. And after 5 you will find 3 here. Now this 3 matches to the description. So in the next place, you can again start with 7. And here you will have 5 options to fill this place. And then what we have is nothing but 3, 5, 3. And the next important digit is nothing but 5. And again there will be 5 cases corresponding to this. And then 3, 5, 3. And then 3 will come. Because 1, 2, 3 were there. And this 3 matches. So now it is the only last digit that you can fill, and this is 7 only. So this becomes 1. So if I add this up, what am I getting? I am getting 5 raised to the power 4 2 times. And now plus nothing but 5 raised to the power 3 1 time. Then 5 square again 2 times. Then 5 again 2 times and then plus 1. If you add this up, it comes out to be 1436. Now this next question is again a very interesting question asked on numbers. So what they're saying is you need to write the numbers in such a manner that x1 is greater than x2 is greater than till x6 and all of these numbers are greater than 0. If I write this in ascending order or increasing order, then the sum of the digits of the number at 72nd place. So now we can see that the same rank based number question that we did earlier, we need to do in reverse order. So let us see how to manage this question. So what we are going to do is we are going to start filling the first place first. So if I put 1 here, then for filling the remaining 5 places, and out of 8, 2, 3, 4, 5, 6, 7, 8, 9, out of this 8 digits I have, I can choose any 5. So you can see that the answer that I will get is 8 into 7 into 6 by 3 factorial, and that is nothing but 8 into 7, that is 56. You can see that the first 56 numbers that are going to come will have 1 at this place. Now if I change this to 2, let us see what happens. 4, 5, 6, 7, 8 and 9. So there are a total 7 digits. So out of this 7, I can choose any 5. And since we are putting in increasing order, we do not need to arrange them further, because arrangement they have already given to us. So if I do this, what I am getting is 7 into 6 by 2. And this comes out to be nothing but 7 into 3, that is nothing but 21. Now if I add this to what you can observe here, what you are getting is nothing but 77. So we have exceeded this number, that is 72. So it is not recommendable that we go till here. So this we cannot do. We need to start counting beyond this. So we need to go further deepen, because the number that we are talking about, 72nd number, will start with 2. So we cannot cross that. So now if I take the second number, let us put 3 here, because numbers are in ascending order. So if I put 3 here, now in that scenario, I need to fill this 4 places by 4, 5, 6, 7, 8, 9 out of this 6. So out of this 6, I need to select any 4. So 6C4. So if I take 6C4, my answer comes out to be 6 into 5 divided by 2. And that is nothing but 3 into 5, that is nothing but 15. So you can see that once I add them, what I am getting is nothing but 71. And from here, if I want to write the 72nd number, now I understand what is going to happen. It is going to start with 2. Then we will write 4 here, then 5, then 6, then 7, and then 8. So this is how I am going to write it. And if I write it down like this, then the sum of these numbers is going to give me my answer. So my answer becomes 2 plus 4 plus 5 plus 6 plus 7 plus 8. And if you actually do it, this comes out to be nothing but 32. Now this 2023 question is very interesting. It talks about a scenario when probably you have lost your pin of your ATM card, and now we are trying to decipher that how many times I need to check in order to get the pin right. Now there are two conditions that they have given here. The first condition is that the greatest number, the guy who has done this, remembers is 7. So if this pin is of 4 digit, x1, x2, x3, x4, the greatest of these numbers he remembers is 7. So what that means is the digits that are involved are 0, 1, 2, 3, 4, 5, 6 and 7. And we definitely know that this one is involved. The rest 3 will come from here. This is what we know after this statement. One more statement what he is giving is, if I add x1 plus x2, that will be equal to x3 plus x4. The sum of the first 2 digit is equal to the sum of last 2 digits. So these are the two conditions that are given to us. Now we have to figure out that how many such possibilities are there for x1, x2, x3, x4, and that he could type and check in order to get the correct pin. So now let us start by making cases. What are the possible cases? So x1, x2, x3, x4, let us take these and understand what can be the possible cases. So what I can do is I can start by taking the value of x1 is 7. Now I can take 7 in the first group also and 7 second group also. So corresponding to every case, we'll see how many cases are possible. Now let us start from here. So if I take 7 here and consider x2 0 here, so what we have is nothing but we have taken this as 7 plus 0. So corresponding to this, x3 plus x4 should be equal to 7. Now what we have done here is we have removed this part and we have removed this. So what we are looking into, if something can add up in between taking these two and could become 7. So if I take 6 here, it will become 1. If I take 5 here, it becomes 2, and it can be done in a very systematic manner, 4, 3. And then these arrangements, what will happen between them, we can calculate it using PNC. First, we are trying to write the cases. Inside the case, what variation will happen, that we'll see later on. Now what I can do is this, if I keep 7 and make 1, then corresponding to this another case would be, let us start with 6 again. So what I want is sum is 8. So 6 plus 2 Then if I take 7 1, so 5 3 can also happen. And then 4 4 can happen, but repetition of digit is not allowed. What they're saying is digits are different. So we do not need to consider that. If I move further and take 7 2, then with 6, what I will require is nothing but 3. So 6 3 is definitely possible. For 7 2, 5 4 is also possible. And beyond this, it will not make any sense. Next, if I write 7 3, it is nothing but 10. And for that, I will require 6 4. That will also become 10. And 5 6, 5 5. But repetition is not allowed, so we cannot take that. If I take 7 4, it becomes 11. Then only possibility is 6, 5. So what we can see that total we have got 1, 2, 3, 4, 5, 6, 7, 8 and 9 cases. Now let us take any one of these cases and see what are the internal possibilities that can happen. So if I take my first case itself, so my first case says that the numbers are nothing but 7 0 6 1. So now one thing what you can do is we have taken 7 here and we can reverse and write this as, so now first we can reverse between them. So if I take my first as 0, so this we can arrange in two ways, and here also we can arrange in two ways. We can, instead of this, we can write 1 6 also. So you can see that corresponding to this we have two choices, corresponding to this we have two choices. Also, instead of putting 7 0 here, I could have put it in the second place. So instead of writing this, what we have written here, alternatively, I can also write 6 1 here and 7 0 in the last two digits. So for this again, two variations will come. So total variations are nothing but 2 into 2 into 2. So corresponding to every case, there are 8 variations that we have. So total variations becomes 8 into 9. That is nothing but 72, which is nothing but our answer. Now, slightly different variation of the same type of question. So what we are writing in this question is we need to make a password consisting of either 6 letter or 7 or characters, or what we want is nothing but 8 characters. What they are saying is these characters can be either these alphabets or these numbers. So total ways of filling each one of this is 10. So I can fill this in 10 different ways. This can also in 10 different ways, so on and so forth. Now what they're asking is in how many ways this can be done so that at least one character is a number. So now this question seems to be very easily done if you use destruction method. So what we can write is we can write total number of ways and subtract when none of them is alphabet. None is alphabet. None is number. Sorry, alphabet we require. So this should give us the answer. So it is quite simple. Now for a 6-digit number, the total numbers could be nothing but 10 raised to the power 6. For a 7, it would be 10 raised to the power 7. And for a 8, it would be nothing but 10 raised to the power 8. Now for the first case, if none of the alphabets, none of the numbers come, then I can fill this first box in nothing but 5 ways, which are nothing but alphabets. If I do it, it becomes 5 raised to the power 6. The second will become 5 raised to the power 7. The third will become 5 raised to the power 8. If you simplify this, we get our number 7 0. Now this, if I simplify, it comes out to be nothing but, what they have given is nothing but alpha times 5 raised to the power 6. So if I divide it by 5 raised to the power 6, the value of alpha comes out to be 2 raised to the power 6. And now plus 2 raised to the power 6 into 10 plus 2 raised to the power 6 into 100. And then minus 1. In the second case, what we'll have is nothing but 5. And in the third case, we'll have nothing but 25. If I simplify this, the value of alpha comes out to be 7073. Quite a simple question. If you look into this 2020 question, in this question, what they're asking is, they are talking about permutations already given in the form of B1, B2, B3, which has 4 elements. These are saying these are 4 element permutation. Notice the word, they have already given you permutation. You do not need to do it. And now what they're saying is in how many ways can this be done so that no element is equal to each other. And another thing that they are giving is there are 2 conditions, B1, B2, B3, either they are consecutive, or B2, B3, B4, either they are consecutive. So if I take my set P as nothing but B1, B2, B3 being consecutive, and set Q as nothing but B2, B3, B4 being consecutive. So we can apply set theory and write number of elements in P union Q. So if I write like this, then N of P plus N of Q minus n of p intersection q should give me my answer. So now let us write number of elements like b1, b2, b3 are consecutive integers. We are taking these numbers from nothing but 1 to 100. So what can happen is basically you can start with 1, 2, 3, and this is the first one. The next can become 2, 3, 4. And if I keep on going like this, then the three numbers can ultimately be written as 97, 98, 99, and 98, 99, 100, like this. So you can see that there are total 98 ways to do so. So the first three numbers b1, b2, b3 can be done in 98 ways. Once you have done that, since no digit or no number is same between b1, b2, b3, the next one can be chosen by the remaining. So if I, for example, if I take this first one, so now the b4 can be chosen from 4 to 100, and these are nothing but again 97 numbers. So the next one can be chosen in 97 ways. So the first part becomes 98 into 97. Second will also be same. There is nothing different. But in the fourth part, now let us say what is happening. So when we are seeing both of them happens, then what will happen in that case? In that case, whatever we are getting are four consecutive numbers like 1, 2, 3, 4. So again, if I write it in like similar manner, 97, 98, 99 and 100 are going to be the last four. And again, you can see in the last case, they are going to be nothing but 97 cases. So minus 97. If we simplify this, the answer comes out to be 18915. Now in this 2021 question, what they're asking is sum of all the 4-digit numbers that can be found using 1, 2, 2, 3. So usually such questions, when given in arithmetic progression, if the digits are in arithmetic progression, we have a shortcut. But since the digits are not in arithmetic progression, we cannot apply that shortcut. We'll have to go using long cut, because even the numbers that are given, two of them are same. So none of the shortcuts will get applied, and we'll have to do it using our core method. So what is the core method? First, let us count what is happening at units place, and then understand the contribution of each of these. So if I put 1 here, then this 1 is going to come how many times? Now in these three places, I will have to put 2, 2 and 1, 3. So this will come in 3 factorial by 2 factorial ways. And since 1 is coming, this is the contribution. And since the place value is 0, this will come. Similarly, if I put 2 here now, things will change slightly, because now we have 1, 2 and 3 to be arranged. So 3 factorial ways to arrange, then 2, and then place value 10 is to the power 0. Further, if I want to do then 1, 1, again here I can put 3. So you can see that here again you have 2, 2, 1 to arrange. So similar as the first case. So this becomes 3 factorial by 2 factorial. And into 3, and then the place value. So what we are getting for the units place, let us write it down. So what we are getting is nothing but 1 into 3 factorial by 2 factorial plus 2 into 3 factorial plus 3 into 3 factorial by 2 factorial into 10 raised to the power 0. This is what we are getting. Now if I know this, then tens place is not very difficult to calculate. The similar thing will happen. It is just that the place value will change. So in that part, if I simplify, similar kind of expression we are going to get. There is going to be not much of a difference there. Just the place value that was earlier 10 raised to the power 0, it become 10 raised to the power 1. So if I do this for all the places and add it up, what is going to happen is we are going to get an expression that looks like this: 1 into 3 factorial by 2 factorial plus 2 into 3 factorial plus 3 into 3 factorial by 2 factorial. And then 10 raised to the power 0 from the first part, 10 raised to the power 1 from second part, 10 square from the third part, and 10 cube for the fourth place is going to come. And this is going to be our answer. And if I do this, what I can write from the first place is nothing but 3. And this becomes nothing but 12. And this becomes nothing but 9. And this becomes, if I simplify, 1, 1, 1, 1. So this is nothing but 24 into 1, 1, 1, 1. That comes out to be 2, 6, 6, 2, 4. And that is nothing but option 1. Now let us look into this another question that was asked in 2022. So unlike earlier question, we talked about sum of the digit. This question talks about product of the digits. So if I take my 5-digit number as x1, x2, x3, x4, x5. So what they're saying is, if I do the product of x1 into x2 into x3 into x4 into x5, this is equal to 36. An interesting thing is, if you factorize this 36, it can be written as 2 into 2 into 3 into 3. So this is how the prime factorization of this number will look like. Now, if I want to make this number, let us see what kind of cases would be possible. So let us start with the maximum values of the digit. So maximum value can happen at 9, and if I multiply other two digits, it becomes 4. So one of the possible scenarios is this might happen, and this is how we'll find a 5-digit number. So this is one of the possible scenarios when the digits are 9, 4, 1, 1, 1. What I'm going to do is I'm going to start with the maximum number and move towards the minimum numbers. Another way to do the same thing would be to write the same thing as nothing but 9, 2, 2, 1, 1. This is also another possibility. Another possibility of expressing it would be nothing but, let us take another biggest digit that can happen is nothing but 6. So if I take one of the numbers as 6, another number can also become 6, and then the remaining numbers can be 1, 1, 1. If I take 6, 3, 2, 1, 1, this is also possible. Once I have taken this digits, now let us say the next can be written as nothing but 3. So I can write 3, 3, and in fact the next can be 4. So if I take one of them as 4, then 4 into 3 into 3 into 1 into 1. And towards that I can take 3, then 3, then 2 into 2 into 1. We have these 6 cases. Now let us see arrangements in these 6 cases. So if I take this first case, it can be arranged in 5 factorial. And 3 are same, so 3 factorial. The next can be done in 5 factorial by 2 factorial into 2 factorial. The next can be done by 5 factorial by 2 factorial into 3 factorial. Next can be done by 5 factorial by 2 factorial. Next can be done by 5 factorial by 2 factorial into 2 factorial. And the last one can be done by 5 factorial by 2 factorial into 2 factorial. Now if you add up all of these cases, and we'll have to add because we add the cases, what I get is nothing but 180, which is nothing but answer up to this question. Now in this 2023 question, they're asking that if I arrange 1, 2, 3, 4, 5, 6, 7, how many cases are possible where neither the string of 153 nor the string of 2, 4, 6, 7 occurs? Now such kind of questions were earlier asked in terms of words. Now they have asked the same question in terms of numbers. So this is an application of set theory in PNC. We call this as principle of inclusion exclusion. So if I take my first case A as nothing but the string of 1, 5 and 3 occur, and if I take my case B as nothing but when the string of 2, 5, 6, 7 occur. So what the question says is number of elements in when A should not also happen and B should also not happen. This is what they're asking. If I apply my De Morgan's law, what we have learned is if I take complement over both A and B, the middle sign, this sign will get flipped. And now this can be written as a total cases minus number of cases in A union B. So this is what we have blended up. Now let us try and find the value. So if I find total number of permutation of 7 letters, 7 numbers, it is nothing but 7 factorial. Then number of A minus number of B plus number of elements in A intersection B we can find. So now if I are talking about string of 153 coming, then there are 4 more things to be arranged. So now what we are doing is in the first case A, 153 will come together, and then there are remaining. So 2, 4, 6 and 7. So we need to arrange these 5 quantities. So arranging 5 numbers would mean 5 factorial. Similarly, in the next case, we have a string of 2, 4, 6, 7. So we are left with 1, 3 and 5. So total arrangements would be nothing but 4 factorial. And if I take them together, in the next scenario, it is nothing but we have one string of 153, another string of 2, 4, 6, 7. Now this can be arranged in only 2 factorial ways. So if I simplify, my answer comes out to be 4898. Now, in this next question that was asked in 2023, based on the strings of numbers, in this question they have clearly given that there are 3 digits already given. Now, this is very important. If you try finding the digits, you will not get the right answer. They've already given the digits ABC, which are in AP. So what does that mean? These numbers are something like this: 2, 3, 4. But they're already given to you. Do not need to choose them. This is very important. So if this is an AP, even 4, 3, 2 will be an AP. So such kind of numbers are given. So now what they're saying is, we want to make a 9-digit number using each of these 3 digits thrice. So for example, if this is the choice of numbers that we have, so we need to take 3 2s, 3 3s and 3 4s in order to make a 9-digit number. But the condition is that this combination of 2 3 4 or 4 3 2 should come at least once. So what we can do in this question is, if I start with this question, what I can do is, I can take this 2 3 4 ones and tie them together using a string. And now what we are left with is 2 2 3 3 4 4. Now if I arrange these 7 numbers, I should get my answer. So if I arrange these 7 numbers, the answer is 7 factorial by 2 factorial, 2 factorial, 2 factorial. Since 2 2s, 2 3s, 2 4s are there, we can arrange this 2 3 4 as 4 3 2 also. So a 2 factorial for that. And this should ideally give us our answer. So if I simplify this, what I get is 1260. And that is our answer. Now this 2020 question that was given to us talks about application of Beggar's method in number-based questions. So let us see what this question says. Question says that there is a 3-digit number. Let us take it as x1, x2, x3. This is made in such a manner that if I do sum of the digits, it is equal to 10. Now this is a clearly Beggar's method based question. So how to do this? So what we can do in this case is, we can write the total number of solutions that are nothing but 10 plus 3 minus 1 C10. Now there is a problem in this solution. What is the problem? First problem is, if x1 becomes 0, it is no more a 10-digit number. So this will happen when x2 plus x3 will become equal to 10, because in the same equation what I have done is I have put x1 equal to 0 in order to get this equation. So these are the cases that I don't want. To let us subtract the solutions of this. This is nothing but 10 plus 2 minus 1 C10, or nothing but 11. So these are 11 cases that I don't want. There is one more value of x1 that we don't want, and that value of x1 is nothing but 10, and 10 is one of the possible values. So if this happens, again we won't be able to get the right answer. So if I put 10 here, then invariably the other two things need to be 0. So this 10 0 0 is one case that we don't want. Let us also subtract this one case. If I remove these two cases, all the cases are relevant. And if I simplify this, this becomes nothing but 12C10 minus 12. So this becomes 12 into 11 by 2 minus 12. And if I take this 12 common, it is 11 minus 2 by 2. And this becomes nothing but 6 into 9. That is nothing but 54. Now again, this is same kind of question that we solved earlier, asked in 2021. So again, here they talk about nothing but 7-digit number. So x1, x2, x3, x7, this is how we can write it. And now what they're saying is, all of these xi's are whole number lying between nothing but 1 and 3. So what they're asking is, how many such numbers are possible so that the sum of this digit is equal to 10. Now directly I cannot apply, because then the minimum value of xi or any of these 7 digits can be 0 and maximum can be 10, and that we don't want. So what we are going to do here is, we are going to do a small substitution. So instead of xi, let me put capital Xi plus 1. So what we are saying is, in place of x1 we will put capital X1 plus 1, so on and so forth. If I do that, the first term becomes x1 plus 1, second becomes again x2 plus 1. We can keep on doing till x7. And if I simplify this, what I get is x1 plus x2 till x7. This will be nothing but equal to 3. And when I'm doing this, what had happened is, because of this substitution, this range has also changed. Now my xi will lie between 0 and 2. Now in the next step, what we can do is, in order to do this question, we can apply Beggar's method. If I apply it, it is 3 plus 7 minus 1 C3. But this is not the right answer, because still by applying Beggar's method, the maximum value of x that I can get in this equation is nothing but 3. So one solution would be 3 and others will become 0. What I'm saying is that those cases we need to subtract. So what are those cases? Let me write one of those cases. So one of those cases is when xi becomes 3 and then x2 to x7, all of these values will become 0. And you can see that such 7 cases are possible. So we need to subtract those 7 cases. And if I do so, I get my answer as 77. So you will have to apply Beggar's method to get to the answer. You can also apply method of cases, but I think this is simpler. If you learn 2 simple steps, this substitution and this removal of excess cases that are coming. Now, a modified form of the last question was asked in 2023. In this question, what they are saying is, again, they have taken 7-digit numbers only. And they are saying the sum of this digit is equal to 12. And now xi is nothing but a whole number that lies between 1 and 4. See, again, we cannot directly apply because the number cannot take value of 12. So let us first put some substitutions, simplify, and then see what are the possibilities. So what we can do here is, I can do a very simple substitution. Xi is equal to capital Xi plus 1, and this is something that we did in the last question also. So in place of x1, I can put capital X plus 1. In place of x2, capital X2 plus 1. Like this, I can go till x7. Capital X7 plus 1 is equal to 12. So the value of capital X1 plus capital X2 till capital X7 will be equal to nothing but 5. And the value of xi, see, if you put this value here, the value of xi comes out to be between 0 and 3. Now again, the problem is that even if I apply my Beggar's method, I will not get the exact answer. The reason is that the maximum value of xi can be 5. If I write my total answers, that is nothing but 5 plus 7 minus 1 C5. I need to subtract 2 very important cases. One is when one of them becomes 5. Now let us see what can be those cases which are not acceptable. So now what we are saying is, if some xi becomes 5. So let us say that if x1 becomes 5, then x2 to x7, all of will become 0. So now this first number you can select in 7 ways. So 7C1 are the possible cases. So these 7 cases need to be subtracted. And another important thing that we do not want is if one of them becomes 4 and another value becomes nothing but 1. This we do not want, because again 4 is not a permissible value. Now this can happen if out of 7, if I select 2 and assign them these 2 factorial values. 1 can be 4, another can be 1, or vice versa. So in this many cases, what I have done is, out of those x1, x2, x3, x4, x5, x6, x7, I have selected 2. Let us say those are x1 and x2, and given them values 4 and 1. If I make this 4, this becomes 1. And if I make this 1, this becomes 4. And that is the reason I have put this 2 factorial in here. So this case also I need to subtract. So if I do that, I get my answer. If I simplify this, I get nothing but 413. So very interesting modification of the question that was asked in previous year, and hence solving PYQs is very important, because little bit of change here, there, and new question appears in the next year JEE paper. Now in this type 4 type of questions based on matrices and determinants, students often wonder that what technique to use to solve such PNC based questions. So in this kind of PNC based question, there are primarily 2 techniques that we are going to use. One is method of cases, and another is nothing but Beggar's method. And by this time, you must have known about my fondness of this method, because the answers come very accurately and very fast. So let us see what kind of question JEE has asked and how to solve those questions. So if I look into this question that was asked in 2022, it is exactly like the question that we just solved. What they're saying is, there is a 3 cos 3 matrix, and the entries can only come from the set of -1, 0, 1. Now they're talking about sum of all the entries equal to being 5. So if I take those 9 elements as x1, x2, x3, x4, x5, x6, x7 till x9, the sum is given as 5. And the value of xi is nothing but -1, 0 and 1. So what I can do is I can use some substitution and some removal of cases or destruction method towards the end to get to the answer. Now let us see how that works out. So in first step, what I'm doing is I am putting a substitution here. So since my xi lies between -1 and 1, in order to remove this negative number, I am putting xi as nothing but capital Xi minus 1. So this substitution is very important, because if I do this and put this here, what you will observe is my xi now lies between 0 and 2. So this I have done because Beggar's theorem or method is only valid for whole numbers. So we need to make it a whole number first. The second step is, now let us write it down. So if I write it down, this becomes x1 minus 1. Then the second term becomes capital X2 minus 1. And this will keep on happening till x9 minus 1. And this is equal to 5. So if I write it down, then x1 plus x2 till x9. And this 9 will go on the other side and make this as 14. Now here, the problem is that the value of xi now lies between nothing but 0 and 2. Still I cannot solve. So we are taking one more step further in the third part. So what is this third step? In this third step, we will talk about a new substitution. So now what we are doing is we are putting xi, capital Xi is nothing but 2 minus y1. Now if this happens, then my y1 will also lie between 0 and 2. You can simply put the value and check. So if this happens, let us see what will happen to the equation that I formed earlier. So let us write the first term as 2 minus y1 plus 2 minus y2. And if I keep on writing that till last term, it is 2 minus y9 is equal to nothing but 14. So what we are getting on the right hand side is 18 minus y1 plus y2 up till y9. Put the brackets, is equal to 14. Or we can write this as nothing but y1 plus y2 till y9 will be equal to nothing but 4. So now it is in the range of applying Beggar's method, because now your yi lies between 0 and 2. So if I write my answer in the third part, still I will not get the right answer, but I can eliminate the unnecessary cases. So answer becomes 4 plus 9 minus 1c4. Now this is not my right answer. I need to remove the answer when one of these takes a value 4. So that can happen is nothing but 9 cases, because if I put y1 is equal to 4, then others will become 0. Similarly, y2 can also become 4. So there are 9 cases. And then one case more would be there when one of them becomes 3 and another one becomes 1. Now in this case, others will take value as 0. So how many such cases are possible? So what you can do is, out of 9, we can take 2 and give them values 3 and 1. So let us say if I have taken x1, it will become 3 and then x2 will become 1 and others will become 0. But then vice versa can also happen. First can become 1 and the other can also become 3. So we'll multiply this by 2. So if I do this and simplify, my answer comes out to be nothing but 414. That is nothing but the answer to this question. Now this 2023 question is nothing but a more intense form of the last question. Now let us see what they are trying to say. In this case, what they are saying is, this is a 2 cross 2 matrix. So if I write this as x1, this value becomes x2, then x3, then x4. First, now what they are saying next is, this xi needs to lie between nothing but 0 and 4. So it can take values 0, 1, 2, 3, 4. Now from here, this is the first part, the actual question starts. The actual question is, the sum of all the elements is equal to nothing but a prime number lying between 2 and 30. So what are the possible values that it can take? So one of the values that it can take is 3. Another value that it can take is nothing but 5, then 7, and then 11. These are the 4 values that it can take, because 2 and 13 are not included. Once you have done this, the next part is to find out the values of possible solutions in all of these 4 cases. So if I take this equal to 3 and xi lies between 0 and 4, it is quite simple. You can directly apply the formula. 3 plus 4 minus 1 C3. This is going to be the answer. In the next case, so this is my case 1. In my next case, x1 plus x2 plus x3 plus x4 will be equal to 5. Now here we know that since xi lies between 0 and 4, Bagger's method will not give me the answer. So even if I write 5 plus 4 minus 1 c5, I need to subtract those cases when this x1, x2, x3 becomes 5. So let us subtract those 4 cases to get the answer. Then comes my next scenario in which x1 plus x2 plus x3 plus x4 becomes nothing but equal to 7. Now in this specific scenario, you will have to do a little bit of hard work. Why? Because if you write the solution 7 plus 4 minus 1 c7, there are a lot of cases getting included that cannot be part of answer. Like when each of them becomes 7. So if one becomes 7, other 3 will become 0. So there are going to be 4 such cases. Another case is if one becomes 6 and another one becomes 1 again, and the 2 becomes 0. And so this case will also arise. So in this, what we'll do is out of 4, we can select 2 and multiply by 2 factorial. Then another scenario would be when it becomes 5, 2, 0, 0. And such cases. So out of 4, I can select 2, give them values 5 and 2 in 2 factorial ways. And there is going to be one third case when 1 becomes 5, then 1, then 1, then 0. So now this can happen in nothing but if I take 3 of them and do this in 3 factorial by 2 factorial ways. So these are the possible scenarios in which it can happen. And if I simplify this, this answer comes out to be 80. Now, if I take my last case would be when x1 plus x2 plus x3 plus x4 becomes 11. In this case, if I do a little bit of substitution and put my xi as nothing but 4 minus ya as I did earlier, my y1 can be written as 4 minus y1. x2 becomes 4 minus y2 and then 4 minus y4 is equal to 11. And this becomes nothing but 16 minus y1 plus y2 plus y3 plus y4 is equal to 11. Or what I get is y1 plus y2 plus y3 plus y4 is equal to nothing but 5. And you can see that this is exactly like the part that we solved earlier. And whatever answer we are getting there will become our answer. So let us calculate this answer also. So this becomes 8c5 minus 4. And if I simplify, it is 8 into 7 into 6 divided by 3 into 2 minus 4. And this becomes nothing but 52. So the answer to this part is also 52. Now, if I calculate, if the first answer, it came out to be nothing but 7 minus 1. 7 minus 1 is nothing but 6c3. So 6 into 5 into 4 by 6. So this becomes nothing but 20. So if I add them up, what I get is nothing but 20 from case 1. From case 2, again, what we got was nothing but 52. From the next case, it was nothing but 80. This was my case 3. And for my case 4, that was sum equal to 11. I got nothing but 52. So if I add them up, what I get is nothing but 204. That is nothing but answer to this question. Now this is quite a simple question. This question talks about a square matrix of order 5. And what they're saying is each of these elements can be 0 and 1. The sum of all the elements in each row is 1 and sum of all the elements in each column is also 1. How many such matrices are possible? So let us start this question. So if I try and make it, what is going to happen is if I put 1 here, then all the other 5 elements needs to be 0. So now I could have put 1 here also at each of the 5 places. So what I have 5 choices to put my 1. Now if I move next, I cannot put my 1 here. So my choices will remain 4. So next time I can put 1 in 4 different cases. And now in all the other places, I can write 0. Now you can see that here and here, I cannot place 1. I have got 3 choices to place my 1. Similarly, in the next case, let us say that I have put it here. So in the next case, what you can do is we cannot put it in the first place, 3 places. Here I can put. So there are 2 choices. And in the last case, we will only be left with 1 choice. If I multiply all of these, I should get my answer. So the answer of this question is nothing but 5 factorial or 120. That is nothing but option D. Now let us start with next problem type. That is nothing but word problems. So now this type of questions are based on nothing but restricted permutation. That means some kind of restriction would be put on the arrangement. Now let us see what kind of question JEE asked. So in this 2023 question, what they're asking is, if I take letters of the word universe without repetition, how many 4-letter words are possible such that they have 2 vowels and 2 consonants each? Now first figure out what are the vowels and consonants in this word universe. So U, I, E and E. These are the vowels. And if I look into the consonant part, it is N, V, R and S. So now what we need to do is we need to select 2 distinct objects out of this. So you can see that there are distinct objects. There are only 3. So out of these 3 I can select. Here there are 4 objects. Out of that I can select 2 different constants. So these are nothing but my selections. Now I need to arrange them. So one of these words will look something like this: UI or UE and V. So if I arrange them, there are 4 factorial ways. So my answer becomes 3C2 into 4C2 into 4 factorial. That comes out to be nothing but 432. Now this 2023 question is again a very simple question. In this question, what they're asking is, all vowels always come together. So first let us figure out what are the vowels. The vowels in this case are I, E, E. So there are 4 E's here. And then if I write the consonants, there are N, D, then P, then again N, then again D, then C. So what we have is nothing but 3 N's, one more N is there, 2 D and 1 P and 1 C. So these are total 7 consonants here and 5 vowels. So now if I want to arrange them such that all vowels come together, so there is a method known as string method. So what we are going to do is, all those vowels, we are going to tie them together using a string. And if I do that, the answer to this question becomes, if I arrange these 8 objects, this becomes 8 factorial. Now out of this 8, you can see that 3 n's are identical. So 3 factorial and 2 factorial, because 2 D's are also same. And now this objects can be arranged inside this string in nothing but 5 factorial by 4 factorial ways. And if I simplify, I get 16800. That is nothing but option A. So whenever the question talks about all vowels together, then we have to use string method. Whenever they say that no 2 vowels together, in that case use gap method. So if all together would mean string method, no 2 would mean using gap method. And if the question talks about not all, then use destruction method. So this is a very small pointer, very important in solving questions. Now in this question, the question talks about no 2 vowels should come together. Vowels never come together. So in this case, we are going to use a destruction method. How does that works out? So what we are going to do is, we are going to find total number of ways minus when all vowels come together. These cases we are going to subtract. So now let us find total number of cases. So there are 7, 3 plus 3, total 6 letters to be arranged. So 6 factorial. 2 E's are same, to divide by 2 factorial. 2 T's are same, hence divide by 2 factorial. Now when all vowels are together, we are going to take these 2 E's and group them together. Then we have L, T, T, R here. So total arrangements would become nothing but 5 factorial. And since 2 T's are same, so divide by 2 factorial. If I simplify this, I get 120. That is nothing but answer. Now in this 2023 question, they are talking about how to make words with or without meaning using all the letters of the word mathematics such that C and S do not come together. So when we talk about two specific letters to not coming together, this is a question based on gap method. So what we can do is, let us write mathematics first. So if I write mathematics, C and S we do not need to include. So these are the letters that we can arrange. First, if I arrange these 9 letters, the total ways are nothing but 9 factorial. Since there are 2 A's, then 2 factorial. Since there are 2 N, hence again 2 factorial. And since there are 2 T's, then 2 factorial. Now, if I take any one of these arrangements, so let us take one of these arrangements that is looking something like this. So you can see that here there are going to be 10 gaps. Like this, if you figure out, there are 10 gaps. Always one more than the total number of objects involved. Out of this, let us take 2 and put this C and S in 2 factorial ways. If I simplify this, I will not get my answer. Why? Because they are telling that this answer is equal to 6 factorial into k. Give me the value of k. So they are not asking us to tell the whole value, just tell the value of k. So if I do this simplification, this is 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2. Divide by nothing but 8 into 10 into 5 and divide by 6 factorial. So 6 into 5 into 4 into 3 into 2. So we can cancel these terms out. If I simplify this, this 8 will also get cancelled out. So what we are getting is nothing but 9 into 7 into, again one more 9 into 10. So if you simplify, it becomes nothing but 5670, which is nothing but our answer. Now in this 2020 question, what we need to do is we need to make a 4-letter word such that 2 letters are distinct and 2 are alike. So first let us say how many same letters are there. So 2S are there, 2L are there, and then what we have is 1Y, 1A, 1B and 1U. So there are total 8 letters. So now you can see that 2 alike letters can be taken from these 2. So in 2C1. And now let us say if I have taken this, then number of distinct letters can be 1, 2, 3, 4, 5. So out of these 5 we can take 2. So one of these selections will look something like SSYA. And this can be arranged in 4 factorial by 2 factorial ways. If I simplify this, this comes out to be 240. So in this 2020 question, what they want us to do is to make a 4-letter word using any of these 11-letter words of the word examination. So the first step in such question is to understand the nature of the letters involved. So if you look into this, E is coming only once, X is coming only once, M is coming only once, T is coming only once, and O is also coming only once. But if I look into A, it is coming twice. If I look into I, it comes twice. And if I look into N, it also comes twice. A very good idea would be to count this and cross check whether these are 11 letters or not, or if you have missed out on something. Otherwise your answer will not match. If you move to the next step, now what we need to do is we need to make cases. What will be the nature of those 4 letters? So the 4 letters can be in such a manner that 2 same. This is first case. Or they can be in such manner that 2 are same but 2 are distinct. Or third, all 4 are distinct. Now usually my technique of making these cases is to start with maximum similarity and go to minimum similarity or maximum distinctness. The reason is that if you do it in this manner, you will not miss on to any case. Because in method of cases, if you miss on to any of the case, your answer will never match. Now let us see what happens in this first case. So 2 same. So there are 3 groups of 2 same each. So out of this we can select any 2. And if I do this, it will look something like AA, II. So their arrangements would be nothing but 4 factorial by 2 factorial into 2 factorial. The next part would be 2 same. So 2 same can be selected in 3C1 ways. And if I do so, I will get something like AA. And now 2 needs to be distinct. So now this distinct can be chosen from 1i, 1m, 1n, e, x, m, t, o. So you can see that there are total 5 plus 2, 7 choices. So out of these 7, I can select any 2. Now this will look something like I, A, I, N. So this can be arranged in 4 factorial by 2 factorial cases. And for the distinct, now total distinct that are possible are 5 are already there. Out of this groups of 2A, 2I, 2N, I can take 1 each. So total distinct things that are available to me are nothing but A, I, N, and then E, X, M, T, O. So total number of distinct things that are available to us are nothing but 5 plus 3, 8. So out of 8, I can select any 4 and arrange them in 4 factorial ways. Now let us add answers of all of these 3 cases, and if I do so, what I get is nothing but 2, 4, 5. So in such cases, all you need to do is make cases. Be very careful in counting the words and the type of words involved. Be very careful in making the cases, because if you miss on to the cases in method of cases, your answer will never match. Now this next 2023 question is based on a concept known as rank of a word. What does rank means is, if I arrange the letters of the word Monday in a dictionary, including all the letters of the word, then in which number that word Monday will appear. Now there is a very small shortcut to do this question. What you can do here is basically, in the first step, arrange the letters of this word Monday in alphabetical order. So we can start with A, then D will come, then M, then N, then O, and then Y. Next step is to write the word whose rank we need to find. So we have written Monday. Now the third step is very simple. Start from 1 less than the total number of letters involved. So total numbers of letters here are 6. So we'll start with 5 factorial. Then write 4 factorial. Then 3. Then 2. Then 1 factorial. And then simply add 1. So what we are going to do here is basically, we are going to write something in multiplication of these 5. Now how to do that? For doing that, what we are going to see is, if my first letter is nothing but M, what I need to check is, before M, how many letters are present here. So you can see that there are 2. So here with 5 you can multiply 2. And now once you have done that, you can cancel out this M for future use. The next, for putting the coefficient of 4 factorial, what we can do is we can choose the next one, that is O. And before O, you can clearly observe there are 3 letters left. So let us write 3 into 4 factorial and cancel out this O as well. Next, what we can observe is, in front of N there are 2. So 2 into 3 factorial. And then ultimately N will also get cancelled out. Now before D there is 1. So 1 into 2 factorial. Also let us cancel out D. Before A there is 0. So 0 into 1 factorial and then 1. So if I add all of these, I get the rank of the word, that is nothing but 327. It is a very elegant and a neat technique to clear your answer. Get your answer really fast. Now in problem type 6, we are going to see those questions which are based on selection of objects and test papers. The common thing or the theme behind all of these questions is the way NCR is being used. Let us see what kind of questions has been based on these ideas. Now this next question asked in 2019 is a combination of PNC and binomial theorem. Let us see how it works out. So what we have been given is 31 objects, and out of these 31 objects, 10 are identical, in remaining 21 are distinct. We want to choose 10 objects. So we can make cases. The first case can be, I can take 0 identical and 10 distinct objects, then 1 identical and 9 distinct objects. Like this, I can go till 10 identical and 0 distinct objects. So for the first one, for selecting 0 identical objects, there is one way. And for selecting 10 distinct, the total number of ways are nothing but 21 C10. For the next part, again 1 identical can be selected in only one way, while 9 distinct can be selected in 21 C9 ways. We can keep on writing this, and the last part also comes out to be 1 into 21C0. Now the answer is going to be sum of all these cases. But when you start adding them up, what we can observe is what we are getting actually is 21C0 plus 21C1 up to 21C10. We need to find this value. Now in the second part, so this is my first part. In the second part, let us apply the binomial result. So what we have got is 21C0, 21C1, then 21C10, 21C11 up to 21C21. This is equal to 2 raised to the power 21. Now what we know is this first term will be equal to last term, and eventually all of these terms will be equal to these terms. So if I write the first part as x, the second also becomes x. So what we have got is 2x is equal to 2 raised to the power 21. So the value of x comes out to be 2 raised to the power 20. And that is nothing but answer to this question. So what have been done is basically the first part is P and C, and in order to simplify the calculation, we have to use binomial theorem. Now this 2020 question talks about at most constant. Now in such question, when they talk about at most, at least, what you need to do is you need to do make cases. At least or at most in very simple language would mean you need to make cases. Now in this question, they clearly say that the number of ways in which 4 marbles can be drawn, so that at most 3 of them are red. So we can start with 0 red, this is first. Then we can have 1 red, second. Then we can have 2 red, third. Then we can have 3 red. So in this way, if I do it, so now in this first case, if 0 are red, that would mean out of the remaining 7, I can choose any 4. So answer becomes 7C4. For the second case, we have 1 red. So out of 5, I can choose 1 red, and remaining 7, I can choose the remaining 3. And then out of 5, I can choose 2. And from remaining, I can choose 2. And from 5, I can choose 3. And from remaining, I can choose 1. So if I add them up, the answer comes out to be 490. A very simple question based on at most and at least constant. Now this 2023 question again talks about at least and at most constant. That means we need to make cases. So what the question says is, Anil's mother want to give him 5 whole fruits. Now what are the options that we have? We have 7 red apples, we have 5 white apples, and we have 8 oranges. Now what she wants to do is she wants to give at least 2 oranges. So at least 2 oranges, 1 white apple and 1 red apple. This is what she minimum wants her child to have. So now in this case, when such kind of questions are given, always make cases. Otherwise it will be either undercounting or overcounting. So what are the cases that are possible? So first case would be to have 2 red apples, 1 white apple and 2 orange. Case 2 can be to have 1 red but 2 white apple and 2 orange. And then there can be a case 3 that talks about 1 red apple, 1 white apple and 3 oranges. Let us try and figure out what is the answer in all of these 3 cases. So first becomes 7C2 into 5C1 into 8C2. The second becomes nothing but 7C1 into 5C2 into 8C2. And third becomes nothing but 7C1 into 5C1 into 8C3. Now since all of them are in themselves complete ways to solve this problem, so we'll add them up. So if I add 1, 2 and third case's answer, what I get ultimately is nothing but 6860, which is nothing but answer to this question. Again, a very simple question based on making cases. So what the question says is, if A set has 5 elements, B set has 2 elements, then the number of subset of A cross B having at least 3 and at most 6 elements. So whenever you see at least at most, think about making cases. So now here, the total number of elements in A cross B would be nothing but number of elements in A into number of elements in B, and this comes out to be 5 into 2 is equal to 10. So a set A cross B has 10 elements. What we want is out of those at least 3 and at most 6 elements. So now what will be the cases? So out of 10, I can select 3. Out of 10, I can select 4. Out of 10, I can select 5. And out of 10, I can select 6. So the beautiful part of this question is not writing this NCR, but how to calculate it. So now you can apply the formula here that NCR plus NCR minus 1 is equal to N plus 1 CR. This will help you simplify calculation. So this becomes 11C4. Simply add 1 here and 1 here. This is how I remember it. Simply here in the smaller one, 1 in the above and 1 in the bottom. So if you do this, this is what we are getting. If you write this part as nothing but 11C7, NCR is equal to NCN minus R. Again, I will be able to apply the formula. And here becomes, and this becomes 11C7. Add 1 to the top and bottom in the smaller one. And now if you simplify, this is 12 factorial by 5 factorial into 7 factorial, which simplifies to 792. Again, a similar question is asked in 2023. Question talks about a boy selecting 5 courses out of 12 courses, out of which 5 are language and remaining 7 are non-language. Constraint is at most 2 language course needs to be selected. So now let us try and understand the cases. The first case is he can take 2 language courses and 3 non-language courses. Second is 1 language and 4 non-language. And the third one is nothing but 0 language and 5 non-language. This first part can be done in 5C2 into 7C3. Next can be done in 5C1 into 7C4. And the last one can be done is 5C0 into 7C5. If you calculate it, this comes out to be nothing but 546. Very easy question. Now this 2020 question is an extremely simple question. They have given us a test scenario in which there are 6 multiple choice questions with 4 alternatives and only one option is correct. Now the candidate has to answer 6 questions in such a manner that exactly 4 are correct. So what you can do in this is, out of 6, let us select first 4 questions which will be correct. Now see, remaining 2 questions can be incorrect. Now every incorrect questions, since there are 4 alternatives, can happen in 3 ways. So first can also happen in 3 ways, the next one can also happen in 3 ways. So the total answer comes out to be nothing but 6 factorial by 4 factorial into 2 factorial into 9. And if you simplify this, this comes out to be 135. Extremely simple question. Again, in 2020, similar kind of question, just little more cases. So if you look into this question talks about 3 sections, each section containing 5 questions. A candidate has to totally solve 5 questions, choosing at least one from each section. So let us make cases. So this is section 1, section 2, section 3. So I have to do at least one from each of the sections. So let us write 1, 1, 1. I'm telling you here how to make those cases. Now think of the maximum number you can put in any of these columns. So what I can do is I can take 3 from here. So 3, 1, 1 is one of the scenarios. So 1, 3, 1 will also be a scenario and 1, 1, 3 will also be a scenario. Or you can take 2, 2, 1 and then 2, 1, 2 and 1, 2, 2. Now let us try and figure out answer corresponding to this. So the answer corresponding to the first one would be 5C3 into 5C1 into 5C1. You can see that the second one is not becoming different, the third also. So all of these 3 could be combined, written as 3 into 5C3 into 5C1 into 5C1. Similarly, if I do the same thing for the remaining 3, answer is going to be 5C2 into 5C2 and 5C1. And I'm going to get the same answer for the remaining 2 also, so into 3. So my answer becomes nothing but 3 times 5C3 into 5C1 into 5C1 plus 5C2 into 5C2 into 5C1. If you simplify that, that comes out to be 2250, and that is nothing but option A. Now let us move towards type 7, that is team formation. Now such kind of questions are based on the idea of NCR and at least at most constant. Let us see what question JEE has based on this idea. Now this 2022 JEE question is nothing but a combination of NCR and some logic in order to get to the answer. Let us see. So what they're saying is the total number of ways of selecting 3 boys and 2 girls is 168. So it has been given there are B boys and G girls in total. If I want to select 3 boys out of B, it is nothing but BC3. And then if I want to select 2 girls out of G girls, then it is GC2. This is given as 168. Now if I write it down, it is B into B minus 1 into B minus 2 divided by 3 factorial. So 3 into 2 into 1. And GC2 will be nothing but G into G minus 1 by 2 into 1. This is equal to 168, and 168 can be written as nothing but 84 into 2, which can in turn be factorized and written as 42 into 2 into 2, and that can in turn be factorized and written as 21 into 8, and that we can write as nothing but 8 into 7 into 3. Now if I take whatever is written in the denominator on the other side, so what we are getting is B into B minus 1 into B minus 2. This is one group. And then we have nothing but G into G minus 1, another group. And this is equal to nothing but 7 into 8 into 3. Then again 3 into 2 into 2. And now let us try and write this 3 into 3 as 9. So what we have got is first group. 9 into 8 into 7. And then what we have got is nothing but 4 into 1. Now this will not cut it. So a better way to regroup would be nothing but 8 into 7 into 6. So why am I writing this 3 consecutive numbers? Because if we have B minus 1, B minus 2, these are going to be 3 consecutive numbers. And then G into G minus 1, another 2 groups of 2 consecutive numbers. So if I write it in this manner, what I can see is basically what I've got is nothing but this and 3 into 2. So if I now compare, a tentative value of B from here can be nothing but 8. And the tentative value of G from here can be nothing but 3. Now let us try and figure out an answer. So what they're asking is B plus 3G. So B is nothing but 8 and 3 into 3. This will become nothing but 9. So answer becomes 70. So you can see that this is a combination of our NCR formula and some common sense to get to an answer. Now this extremely simple question came in 2021. Question talks about making a scientific committee in which out of 6 Indians and 8 foreigners, out of which 2 Indians at least needs to be included and double the number of foreigners as Indians need to be included. See, in this question, whenever you see at least constant, again you should think about making cases. So your first case can be when you take 2 Indians and 4 foreigners. Your case 2 would be when you take 3 Indians and 6 foreigners. Your case 3 would be when you take 4 Indians and 8 foreigners. If you do this, the answer corresponding to first case comes out to be 6C2 into 8C4, corresponding to second 6C3 into 8C6, and corresponding to last one 6C4 into 8C8. Once we add all of them down, it comes out to be 1625. That is nothing but option 3. Now again, an extremely simple question in 2019. This question talks about you have to make a team of 2 girls and 3 boys out of 5 girls and 7 boys, such that 2 specific boys A and B should not be there in the same team. So now there could be 3 cases. One, both A and B are not included. This is a very important case. This is my case 1. So what I can do is out of this 5 girls, I can take 2 girls. Out of remaining 5 boys, I can take 3 boys. Another case could be A, either A or B, no, but not both are included. Now, in this case, what you can do is, out of 5 girls, we can take 2 girls. But out of the 5 boys now, we can take only 1 boy. And out of, 2 boys. And out of those 2 boys, A and B, I can take 1. If I sum this up, it comes out to be 300. That is nothing but option D. Now, similar kind of question is again been asked in 2022. So it is a repetition of 2019 question. You can see little bit of data is changed. The answer of this question comes out to be 1120. You can check out this question. Again, similar kind of question has been asked in 2019. Now, this question talks about number of games being played between M men and 2 women participating in a chess tournament. Now, what they're saying is each participant plays 2 games with every other participant. And then they are saying that number of games played by men. So number of games played by men would be nothing but if I select 2 men, they will play 2 games each. Exceeds by the number of games played between men and women. So now if I take men, it is MC1 and women again NC1, and the number of women is given as 2 in the starting. And into 2 will be equal to 84. We need to solve this equation and get to an answer. So if I do that, this becomes m into m minus 1. The second part becomes nothing but m into 2 is equal to 84. And if I simplify, this becomes m square minus m minus 4m minus 84 is equal to 0. And this becomes m square minus 5m minus 84 is equal to 0. And now if you simplify this, 84 can be written as nothing but 42 into 2. It can also be written as nothing but 21 into 4. And can also be written as 7 into 12. So if I do this, I can write this as nothing but m minus 12 into m plus 7 equal to 0. Since m cannot be negative, the value of m from here comes out to be 12. Quite a simple question. Now, similar type of question was also asked in 2021. In this question, they are talking about 2 teams, A and B, consisting of 7 boys and girls, 4 boys, 6 girls. Now, what they're saying is 52 single matches are played in such a manner that the boys of both the teams play together and the girls of both the team play together. So now we can say that 52 will be equal to, if I take 1 boy from team 1 and 1 boy from team 2, plus if I take 1 girl from team 1 and 1 girl from team 2. So this becomes 52 is equal to 7 into 4 plus 6n. And if you solve this, n comes out to be 4. Extremely simple question. Now let us look into this next question. In this next question, they are talking about a mixed doubles badminton match to be played between some couples, let us say n couples, in such a manner that in a match, no couple plays a match. The total number of ways are 840. We need to find total number of people who participated in the tournament and not couple. So our final answer is going to be nothing but 2n. This we need to understand because this mistake can also happen. Now let us say that how many such ways are possible. So what you can do is out of n males that are there, let us choose 2 males. These are going to play the tournament. And out of remaining n minus 2 couples, let us choose 2 females who are going to play the tournament. And now let us say that we have taken this male 1, male 2, female 1, female 2. So you can see that there are 2 types of pairing possible. So into 2. So this many matches are possible. And this is given nothing but equal to 840. After this, what you can do is we can simplify it. So this becomes n factorial by n minus 2 factorial into 2 factorial. Other part becomes n minus 2 factorial by 2 factorial into n minus 4 factorial into 2 will be equal to 840. And if I simplify this, you can see n minus 2 factorial gets cancelled out. This 2 will also get cancelled out. And what we are getting is n into n minus 1 into n minus 2 into n minus 3. And this will be equal to 840 into 2. And if I do this and simplify, this is nothing but 42 into 2 into 2 into 5 into 2. This 3 2's can be written as 8. Now the remaining can be written as nothing but 21 into 2 into 5. And this we can refactorize and write as 8 into 7 into 6 into 5. So if I observe both the sides, what we can observe is the value of n is nothing but 8. If the value of n comes out to be 8, the answer of this question comes out to be 2n, that is nothing but 60. Now let us move towards type 7 problem, that is geometrical problem. Again, these are the problems based on NCR only. And largely speaking, there are few categories. There are categories of problem based on points, problems based on lines. Then there are problems which are based on polygons. Then there are few problems which are based on the idea of grid. So these are prominent 4 category of problems that are usually asked in this section. Let us see what JEE has asked on this area. If I start with this next 2024 question, this question is a very simple question. It says that you have a triangle and on the sides of the triangle there are certain number of points. So what they have given is on side AB there are 5 points in between. On side BC what they have given is basically there are 6 points. And on side CA there are nothing but 7 points. And if you add them in total there are 18 points. They want to make a triangle such that taking this as vertices. So now an easier way to do this question would be, what we can do is again use destruction method. Out of 18 points, choose any 3 points. You will get a triangle. But sometimes the triangle will not get formed. Let us subtract those cases. So one of that case would be when all of the points are on side AB. So if we can subtract that 5C3. One more case could be all the points can be on BC. So we can subtract those 63 points. And one more case can be there when all the points are nothing but on AC. So we can also subtract 7C3. If you simplify this expression, it comes out to be 75. That is nothing but option. Now let us look into this 2021 question. In this question, what they are saying is, if you have a rectangle ABCD, on this rectangle, on the side AB, BC, CD and DA, there are respectively 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. And on CD there are 1, 2, 3, 4, 5, 6. And on AD there are nothing but 1, 2, 3, 4, 5, 6, 7, 8, 9 points. What they're saying is, let alpha be the number of triangles having these points from different sizes vertices. So now in order to calculate alpha, what we need to do is, we need to first consider the cases. So one type of triangle we can find by taking AB, BC and CD respectively as sides from which we are choosing vertices. If I do this, my answer corresponding to this comes out to be nothing but 5C1 into 7C1 into 6C1. Then what I can do is, then I can take AB, BC, but instead of CD, I am taking AD. So if I take this case, my answer comes out to be 5C1 into 7C1 into 9C1. The next, what I can do is, I can take AB, skip BC, but take CD and AD. If I take this case, 5C1, since I have skipped BC, 7C1 will not come up. Now 6C1 will come and then 9C1 will come. And in the last case, what you can do here is you can skip AB and take BC, CD and AD. With this, we have completed all our cases. So if I do this, it becomes 7C1 into 6C1 into 9C1. Now, how do I know we have covered all our cases? Because if there are 4 sides, total number of ways of taking 3 sides is 4C3, that comes out to be 4. And we have already considered 4 cases, so all the cases have been covered. If I want to find the value of beta, what they're saying is, again, we want to find a quadrilateral taking points from different sides. So from first side 5c1, from second one 7c1, from third one 6c1, and from last one 9c1. If I do beta minus alpha now, it comes out to be 7. Now, this is a very interesting question that was asked in 2023. This question talks about a triangle formed by x-axis, y-axis, and a line that is given to us as 3x plus 4y is equal to 60. Now, they're saying that there is a point A comma B here in such a manner that B is a multiple of A. This is what is given to us. So we need to find how many such points are possible. So a very simple way of doing this question would be to start putting values of x, because we want points which lie strictly inside the triangle. So if I put x equal to 1 here, in that case 4y will be equal to 57, and the value of y approximately comes out to be 14 point something. So what we can say is, for x equal to 1, the possible value points that can lie inside are nothing but 1 comma 1, 1 comma 2, and we can go till 1 comma 14. You can see that there are 14 such points that are there for x equal to 1. Let us do the similar kind of calculation for nothing but x equal to 2. So if I put x equal to 2, my 4y will be equal to nothing but 54. Y would be nothing but 13 point something. So now what is happening here is, corresponding to this, the possible values are nothing but 2 comma 2, because we want multiples, not just the point that are inside. Then 2 comma 4 will also be there, and like this, then 2 comma 6 will also be there, 2 comma 8 might also be there, 2 comma 10 might also be there, and then 2 comma 12 might also be there. So 1 2 3 4 5 6. So we are getting 6 values from here. If I move forward and put the value of x is nothing but 3, now 4y would be equal to nothing but 51. The value of y would be nothing but 12. So we can see that since we want strictly inside points, it would be nothing but 3 comma 3, 3 comma 6, 3 comma 9. So from here we are again getting 3 more points. If I keep on doing the same thing for x equal to 4, let us see what happens. If I put x equal to 4, 4y would now be equal to 48, and if I divide this, this again comes out to be 12. This was 12 point something. So we have missed out on 1 point. 3 comma 12 will also come, because this is 12 point something. Here if I put 12, so now again corresponding to this, if I write points, it will be 4 comma 4, 4 comma 8, and 4 comma 12 I cannot include because we want strictly inside points. So 2 points we have got. Now if I move further and put the value of x as nothing but 5, let us see what happens. So my 4y 45, value of y becomes nothing but 11 point something. So possible point becomes 5 comma 5 and 5 comma 10. So there are 2 points corresponding to this. Next is x is equal to 6 we can put. So here 4y is nothing but 42. Again point something will get. So the point becomes nothing but 6 comma 6. That's it. And we can go on doing the same thing till x equal to 9. So till x equal to 9 if I put now, then 4y will be equal to 60 minus 3 into 9, that is 27. And 60 minus 27 is nothing but 33. So the value of y comes out to be 33 by 4. That is nothing but 8 point something. And you can see that once we cross 9, this value is smaller than it. So we will get no multiple of 9 comma and multiple of 9 will never get. So if I sum it up, what I get is 14 plus 6 plus 4 plus 2 plus 2 plus 1 for 6, 1 for 7, 1 for 8. If I add it up, it comes out to be 13. Now this next question is extremely simple. This question talks about a polygon being formed using 20 pillars. And now what they're trying to count here in that polygon is the diagonals of the polygon, because we are trying to connect not the adjacent side but non-adjacent sides. So if you connect non-adjacent sides, what you are going to get is nothing but the diagonal. We have a direct formula for that, but I will derive that formula for you. So if you have an n-sided polygon, so if I take NC2, it means I am taking any 2 points out of n, and this will either make a side or a diagonal. Since I want diagonal, this number of sides, that is n, can be taken on the other side. So number of diagonals for a polygon is nothing but NC2 minus n. If you put value in this, what you get is 20 C2 minus 20 in this case, which simplifies to 170. That is option C. Now this next 2019 question involves some basic sequence series and PNC. So what they're saying is, if we start making an equilateral triangle with 1 ball, then 2 ball, then 3 ball, like this. So total number of, if let us say total number of rows are n, then number of balls would be used would be 1 plus 2 plus 3 until n, and this is nothing but n into n plus 1 by 2. Now what they're saying is, if we add in this 99 more balls, it will be equal to a square of n minus 2 side. If I do this, I get an equation, and if I solve, n square plus n plus 198 would be equal to 2n square minus 8n plus 8. So the equation that we are getting is n square minus 9n plus minus 190 equal to 0. And if you solve this, the value of n comes out to be 19 from here. Once you have got this, what they're asking, what is the total number of balls used to form equilateral triangle? Now this is quite simple. We just need to substitute value of 19 here. So 19 into 20 divided by 2 comes out to be 190. That is nothing but option B. Now this 2024 question is a very famous question. In this question, what they're asking is number of triangles that can be formed from this polygon that is given as a regular octagon, that none of these sides are sides of an octagon. So we are going to use destruction method. What this method means is, let us write total number of triangles, and out of this let us subtract those triangles which have 2 sides common, and also subtract those which have 1 side common. So if I subtract this, I will get the one which none of them common. Now the first one is the simplest one to find. What we can do in order to find this first one is, out of 8 points I can choose any 3 points and I will get a triangle. If I want to get at least 2 sides common, let us draw a small diagram and understand what is going to happen. So what is going to happen is, if I start from here, 1, 2 and 3 is common, so this will become a pair. The next 2, 3, 4 will become a pair. So if you start counting, what is going to happen? You will have 1, 2, 3 as one pair. Then 2, 3, 4 vertices another pair, and this will go up till 8, 1, 2. So you can see that there will be 8 such cases, and generally speaking, for any polygon there will be n such cases if it is an n-sided polygon. So answer for this next part comes out to be nothing but 8. And for one side common, let us also do this. For one side common, what is going to happen? I can take one side in 8 ways. Let us say that I have chosen this side. then corresponding to this side, what you can clearly understand is, now you can't take this point because then two sides will become common. Of course, this we can't take and this we can't take. So 4 points we can't chase, rest 4 we can take. So we'll multiply by 4. If I figure out the answer, this will become nothing but 8 factorial by 5 factorial into 3 factorial. If I simplify this, this becomes 8 into 7 into 6. This will also get cancelled out. This is 8 and this will become 32. If I simplify, my answer comes out to be 60. That is nothing but option B. Now let us look into the next type of problem, that is nothing but distribution of distinct objects. Now first let us understand some basic theory and then see what kind of question JEE has asked on it. So let us try and understand this scenario that if you have 10 distinct objects and we have to distribute into 5, 3 and 2 groups, we can do this by 10 factorial by 5 factorial into 3 factorial into 2 factorial. And now if I want to give these groups to 3 different people, then the answer is going to be nothing but 10 factorial by 5 factorial into 3 factorial into 2 factorial into 3 factorial. So only this 3 factorial is coming as extra, remaining all the things are same. Now the interesting part happens when we have 2 of these groups of equal sizes. So then your answer becomes 10 factorial by 3 factorial, 3 factorial, 4 factorial. This is fine. But since 2 are same, hence 1 by 2 factorial will come. And then in the next part, we will write the same answer. Then in the next part, the answer becomes 10 factorial. So copy paste whatever we have written earlier and just multiply by 3 factorial because we are giving them to 3 distinct people. The next part says that if you have 2 of one size, 2 of another size, and we are dividing into 4 groups, then 10 factorial by 3 factorial whole square into 2 factorial whole square. Since the first two are of same side, so 1 by 2 factorial for that. Since the next two are also of same type, so 1 by 2 factorial for that. If you want to write the answer, when we want to give this to people, my answer becomes nothing but 10 factorial by 3 factorial whole square, 2 factorial whole square. This 2 factorial will also we will write 2 factorial raised to the power 2. And since being given to 4 people, hence into 4 factorial. So whatever is the number of people that we are giving it, that much factorial will get multiplied to it. Now in this 2023 question, what we need to do is 8 people need to be transported in 3 cars from city A to B, and the cars are also different. And this needs to be done in such a manner that every car can have at most 3 people. So if I am putting 3 here, the remaining will contain 2. Now if I do this, this is the only possible scenario that is there, and corresponding to this, if I write my distribution, it is going to be 8 factorial by 3 factorial into 3 factorial into 2 factorial. Since these two are same, we will put 1 by 2 factorial. And since it is getting distributed into 3 different cars, hence multiplied by 3 factorial. And if you simplify this, this comes out to be 1680. That is nothing but option B. Now let us look into this first question that was asked in 2023. This question talks about 20 distinct oranges being given to 3 children such that each children gets at least 1 orange. So we are going to use the method of destruction. So the total base of distributing 20 distinct oranges to 3 children would be, so each orange, let us say this is orange 1, will have 3 options: children 1, children 2 and children 3. Similarly, the next one will also have 3 options, and like this all 20 oranges will have 3 options. So total number of ways are nothing but 3 raised to the power 20. Now we want to remove those cases now which are not following this condition. So what we can do is we can select 1 children out of 3 children and give all 20 oranges to him in one way. Or what we can do is basically out of 3 we can select 2 and then give all 20 oranges to those 2 people. So this can be done in 2 raised to the power 20 ways. But we need to subtract 2 ways in which all the oranges are given to only one person. So if we do this, we are able to get our answer. Now let us look into this next question of 2021. It is a slightly more complicated question than earlier. So what we are saying is S1, S2, S3, S10, we are getting divided into three groups ABC. Now let us write these three groups ABC. Condition is that all should get at least one, but 3 has at most 3 students. So let us put 3 students here, 2 student and 1 student. Let us consider these 3 cases because it is a question based on at least constant, and hence cases making is one of the important things. So if you take 3 students here, so how many ways this first thing can be done is, out of 10 students I can choose 3 for here. For the remaining student you have two choices, either they can go to A or B, and this choices can be exercises by all the 7 students, so 2 raised to the power 7. But we need to subtract two cases where all the students will go to either A or B, because every set needs to have at least one student. In the second part we can do 10C2 into 2 raised to the power 8 minus 2, and similarly in the third part we can do 10C1 into 2 raised to the power 9 minus 2. If we sum it up, we get nothing but 31650, which is nothing but our answer. If I look into this 2024 problem type, problem of 2024, you can see that what they're saying is, this is the problem of distribution. You have been given terms from 2 to 5 and 12. And if you want to calculate how many terms are there, these are in geometric progression. So 5 and 12 can be written as A into R raised to the power n minus 1. A is 2, R is also 2, and this can be written as 2 raised to the power 9. You can see that 2 raised to the power 8 will be equal to 2 raised to the power n minus 1, n comes out to be 9. So there are total 9 elements. Now what they are saying is, in the next part, we'll have to draw a little bit of Venn diagram to understand. There are 3 sets in such a manner that all the elements should go into these 3 sets only, but none of them can go into the intersection part. So from here, nothing can go. You can see that every element should go into these 3 parts only, because the union is equal to sample space and intersection cannot be there. So that fundamentally means, or reduces into a very simple question, that we need to divide these 9 elements into groups of 3, 3 and 3 elements. And this needs to be given to A, B, C, these 3 distinct sets respectively. So answer to this question comes out to be nothing but 9 factorial divided by 3 factorial, 3 factorial, 3 factorial. Since these 3 are same, so 1 by 3 factorial one more time. And it needs to be given to 3 distinct sets, hence into 3 factorial. If you calculate this, the answer reduces into 1680, and that is nothing but option D. Now if I look into this 2024 question, this question clearly says that there are 4 men and 5 men in group A, and then there are 5 men and 4 women in group B. What they want us to do is make or select 4 people out of this in such a manner that there are 4 men and 4 women in each of the group. From each group they also want to select 4, and the 4 should be men and women also. See, whenever a lot of constraints like this are placed, and we call this as at least at most constraint. Whenever such constants are placed, a simple way to do the question would be to make cases. And this is very important to remember. Do not do anything, just make cases. So if I start making cases, let us make a small table. Let us write men and women here, and then also write group A and B here. Now what I can do in the first case is, I can take 4 men from here, 0 women from here. In order to balance the overall selection, I will have to take 0 and 4. This is the first case. Correspondingly, I can have another case. In this case, let us first do the selections. So in this case, if I want to select out of 4 men, and because A group had 4 men, if I want to select 4, it will become 4C4. And out of 5, if I want to select 0 women, it is 5C0. In the next one, it is 5. So 5C0 into 4C4. You can see that corresponding to this, the answer will come out to be 1. This is the first case. In the next case, let us do so, and I am changing the color so that it is very easy for you to recognize. I can take again AB. Now what I will do is, I will reduce this by 1, increase women by 1. It will have to compensate by doing 1, 3 here. And if I do so, correspondingly, if I want to write the answer, it will become 4C3 into 5C1 into 5C1 into 4C3. Now if I want to find the answer corresponding to this will become 4. This will become 5. And the similar thing will happen from the other side also. 5 into 4 will come. And this will become nothing but 400. Now let us keep on doing the same thing. In the next case, if I make to this, and this table method is very simple to implement also. If I take 2 from here, this will become 2. This will also become 2. This will also become 2. Correspondingly, out of 4, I will have to take 2. Out of 5, will I have to take 2. 5C2, 4C2. Now, if you find the value of 4C2, let us see what happens. So, 4C2 value is nothing but 4 into 3 divided by 2. So, that will come out to be 6. So, this is 6. 5 into 4, that is 20 divided by 2. This will become 10. So, 10 into 6. So, this becomes 3600. Next case again, let us do. So, in the next case, what you will observe is, in this case, now this will become 1, this will become 3. 3 and 1. If I find the answer, what I am getting is nothing but 4C1 into 5C3. 5C3 into 4C1. And again, if you observe the answer, 4C1 becomes 4. 5C3 will be exactly same as 5C2. So this becomes 10. Then 10 into 4. So 4 into 10 into 10 into 4. This comes out to be nothing but 1600. Let us take one more case, and that would be our last case, in which if I take A and B, so this will become 0, this will become 4, this will become 4, this will become 0. And corresponding to this case, you can see the answer becomes 4C0 into 5C4 and 5C4 into 4C0, and the answer will correspondingly become 25. Now we can see that if I add the answers of all the cases, what do we get? In the first one it was 1, then it became 400, then it became 3600, then it became 1600, and the last case was nothing but 25. It adds up to 5626. Now this very interesting question came in 2024. See, usually students have this habit of distributing distinct objects into distinct categories. Now this question tries and changes that. If you see from permutation combination point of view, it is very important to understand that when we are doing distribution, what can happen? Object and then categories. What can happen is, there can be 4 different cases. One is this is distinct, this is distinct. These are the all questions that we have seen till now. This can become distinct, but this can become identical. This can become identical, this will become distinct. This we are going to see in the coming problem types. And both of them can become identical. This is also possible. You can see that technically there are 4 questions and distributions that are possible. We've already taken care of this first category of questions. Now we'll move towards this next category, which is a further sub-problem type of the same thing. In other words, we'll also call this categories distributing into groups. So this is also known as distribution into groups. So what will happen is that additional 2 or 3 factorial that we used to multiply in order to take care of the distinction between the categories that we used to have, that will not happen now. Like there were people which we are giving some distinct number of chocolates, that we are not doing because of the people are identical or twins or triples. So now if you look into this question, it says that if n is the number of ways in which 5 distinct employees, so you can see that the objects that needs to be distributed are distinct, but they are getting distributed into indistinguishable offices. This is the case. So what we fundamentally need to do is we need to divide this 5 different employees into groups. The grouping concept again will come into picture. So what are the possible distributions that are possible? So what I can do is I can distribute like this: 5 0 0 0 0. 4 offices, so only 3 zeros. So this is one possible category, and corresponding to this, the answer will become 5 factorial by 5 factorial, because there is only one office in which you are placing 5 people, and then the offices are identical, so it is not going to matter. So answer becomes 1. In the next one, we will take 4 in the first one, 1 in the next one, and this is the grouping that we want to do. So see, when we are doing this grouping, it is only important to pay attention to what is happening. What is not happening is unimportant. So we need to distribute 5 objects into group of 4 objects and 1 object. So our answer corresponding to this becomes 5. Moving forward, another way of doing things would be if I take 3. then 1, 1, 0, this is possible. Now corresponding to this, the answer will become 5 factorial. We are dividing this into group of 3 and 1. So answer becomes 3 factorial into 1 factorial into 1 factorial. Since both of these are identical, we'll also have to divide by 1 by 2 factorial, as I told in the starting. So answer for this becomes 10. Moving forward, the next would be nothing but 3, 2, 0, 0. Now if I do this, the answer corresponding to this becomes 5 factorial by 3 factorial into 2 factorial. So answer becomes nothing but again 10. Moving forward, what I can do is I can have 2 here, then 1, then 1, then 1, and then if I calculate the value of this becomes 5 factorial by 2 factorial, and see that 3 are identical. So this again becomes 3 factorial. So answer corresponding to this again becomes 10. And the last category is if you have 2, 2, 1. You figure out the answer in this category, it becomes 5 factorial by 2 factorial, 2 factorial. Since 2 are again same, again 2 factorial. Answer corresponding to this becomes 15. If I add all of them, 1 plus 5 plus 10, you can see that 10 will come 3 times. So let us multiply 3, then 115. You can see that this will become 45 plus 6 becomes 51. Hence option C comes out to be correct.
Now next, let us move on to the type 10 problem, that is nothing but distribution of non-distinct objects. These kind of problems are direct application of Beggar's method. Let us see how these questions can be done. Now this next question is extremely simple. What we can do in this 2023 question is, let us put the values here, substitution. So in place of x, we can put capital X plus 1. In place of y, small y, we can put nothing but capital Y plus 3. And instead of this small z, we can put capital Z plus 4. And if I do so, capital X plus 1, capital Y plus 3, capital Z plus 4, this will be adding up to 21 if I put it here. So capital X plus capital Y plus capital Z is 3 plus 1, 4 plus 4, 8. So 21 minus 8. And if I subtract 8 from here, this becomes nothing but 13. So once I get 13 from here, my job is very simple. I can apply Beggar's method. So 13 plus 3 minus 1, C13. And this comes out to be nothing but 16 minus 1, so 15C13. That is equivalent to 15C2. And now this can be written as nothing but 15 into 14 and divided by 2. So 15 into 7. That comes out to be nothing but 105. In this 2023 question, there is a very important word that you might miss out. X and Y are distinct non-negative integers. So both the words are important, distinct also and non-negative also. So basically we are looking for whole numbers. Now this is in the purview of Beggar's formula, so very good. But this is not in the purview. So we need to isolate these solutions from the total solutions. If I write my total solutions for xy plus z is equal to 15, where nothing but xy z belongs to whole number, the answer is nothing but 15 plus 3 minus 1, C15. And this, if you simplify, comes out to be 136. Now these are my total solutions where some of them 2 will be same, 3 will be same. So out of this, let us subtract those solutions in which all are same and exactly 2 same. These solutions we need to subtract. Now see, all same is very simple to find. So let us first find when all will become same. So what we can do is, in this equation, x plus y plus z is equal to 15. We can put simply x is equal to y is equal to z. So thrice of x is equal to 15. X comes out to be 5. So you can see there is only one such solution. In the second part, what I can do is I can try and figure out when 2 are same. Now 2 can be same. So either x and y can be same, y and z, or z and x. These 3 scenarios may apply. So I am taking this scenario and I will multiply my answer by 3. So if I take this, then twice of x plus z would be equal to nothing but 15. Now we can see that in this
we can put x is equal to 0, 1, 2, 3, 4, 5, 6 and 7. It will get satisfied. So you can see that there are total 8 solutions, but we cannot take all of these 8 because one of these solution is 5 that we got earlier, for which all the 3 solutions will become same. So we need to subtract that one. So my answer comes out to be 7. So there are total 7. So now let us put the values here. So if I put my values, 136 is fine, but this one also needs to be subtracted, and then 3 into 7. So 7 was for this one case. We have 2 more such cases. So it will become 21. And if I do so, my answer comes out to be 114. That is nothing but option D. If I look into this 2022, it is a very interesting question. What they are saying is there are 16 identical cubes, out of which 11 are blue and 5 are red. This is what they have given to us. We have to arrange them in a row so that between any 2 red cubes, there should be at least 2 blue cubes. So what we can do is, if I write this R, red, red and red, 5 reds in a row. So you can see that between them and around them, there are going to be 6 gaps. Let us say that in this first gap, we are filling x1 cubes, in the second one, x2 cubes, in the third one, x3 cubes, similarly x4, x5 and x6. So these are nothing but the blue cubes that we are filling in this position, arranging in this position. Now the condition is that for this x2 to x5, x3, x4 and x5, this value should be greater than equal to 2. So now let us write it down. So in mathematical terms, so this is the conceptualization in first part. In the mathematical terms, it looks like x1 plus x2 plus x3 plus x4 plus x5 plus x6 should be equal to 11. My x1 can take any value greater than equal to 0. For x2, x3, x4 and x5, it needs to be greater than equal to 2, and for x6 again greater than equal to 0. Now this can again be in turn solved using Beggar's method. So what we can do in the third step is we can do substitution. So x1 and x6 is fine, but for x2 we can put it equal to capital X2 plus 2. x3 we can put it equal to capital X3 plus 2. So on and so far till x5, capital X5 plus 2. See, why are we doing this? The reason is that Beggar's method only will give us answer for whole numbers. Now when you are writing greater than equal to, it is not a whole number. So we are doing this substitution to make it to that whole number level. So now once you do that, what you have is a small x1 plus capital X2 plus 2 plus capital X3 plus 2 plus capital X4 plus 2 plus capital X5 plus 2 plus x6 is equal to 11. And if I simplify, I get an expression x1 plus capital X2 plus capital X3 plus capital X4 plus capital X5 plus small x6 is equal to nothing but 3, because this 2, 2, 2 and 2 will become 8 and right hand side becomes 3. So once you have got this, now we can apply Beggar's theorem. Why? Because now all the variables that we are talking about are whole numbers. So my answer comes out to be nothing but 6 plus 3 minus 1 C3, that is nothing but 8 C3, and that is nothing but 56. So important thing while applying Beggar's theorem is it is only applicable for whole numbers. So if whole numbers is not given in the current equation, put some substitution and bring it to that form. Now this 2021 is a very typical problem, a classroom illustration. Now in this question what they are saying is number of positive integral. Now this you need to observe, sometimes they will write integral and then the answer will change, of x by z such that x into y into z equal to 24. So the method of this question goes like this. First you will, in the first step, you will write the prime factorization of 24, and that is nothing but 3 into 8 or 2 cube into 3 raised to the power 1. See, now if I am writing x, what can happen in x? We will have some power of 2, let us say that power as a1, and some power of 3, let us say that as b1. Similarly, we'll have y is equal to 2 raised to the power a2 into 3 raised to the power b2. And similarly, we'll have z, that is nothing but 2 raised to the power a3 into 3 raised to the power b3. Now, if I multiply all of this, see, I am only taking these two prime numbers because if there are more, then in prime factorization that will get reflected. So, if I am multiplying x, y, z, let us see what am I getting. So, I get 2 raised to the power a1 plus a2 plus a3. 3 raised to the power b1 plus b2 plus b3,
And now they have given that this is equal to 24. And that is again in turn 2 raised to the power 3 into 3 raised to the power 1. So if I compare this in the third step, something very significant happens. What I get is nothing but the value of a1 plus a2 plus a3. This should be equal to 3. And we have one condition, and b1 plus b2 plus b3, this should be equal to 1. So our answer is nothing but multiplication of these two. So if I solve it further, this comes out to be nothing but 3 plus 3 terms on the left hand side minus 1 c3. And the answer for the next one comes out to be nothing but 3 plus 1 minus 1 c1. And the answer becomes nothing but 5c3 into 3c1. 5c3, if I simplify, becomes 5 into 4 by 2 and 3. This comes out to be nothing but 30. And that is nothing but option 4. Now let us look into this question of JEE 2022. Now in this question, specifically we'll have to use multinomial theorem to get to the answer. The reason is that there are multiple cases that are getting found. Now let us see. So question says that there are 30 identical candies to be given to 4 children, C1, C2, C3, C4. And what they're saying is C2 gets at least 4 and at most 7. C3 gets at least 2 and at most 6. See, whenever the question is lot of modification going on, in this scenario only multinomial will make sense because your calculation, thinking, everything will get satisfied. So let us start with this question. So what I can say is, if I am writing C1 is the candy received by children 1, then children 2, then children 3, then children 4, it is equal to 30. Now the conditions are C1 can lie between 0 and 30. But for C2, there is a condition, it needs to lie between 4 and 7. C3 again could lie between 2 and 6. And C4 again would lie between nothing but 0 and 30. Now using these conditions and this statement, if I write the multinomial theorem, so this is the first part. Second step now we are doing. So in the second step, what we can say is the variation of C1 can be from x raised to the power 0, x raised to the power 1 up till x raised to the power 30. It can get 30 chocolates. The second one, again, x raised to the power 4, 5, 6 and 7. The next part, if I see, the variation will be from x raised to the power 2, x raised to the power 3, 4, 5, 6. And if I multiply, the last part will again start from x raised to the power 0, 1, 2, 3 and x raised to the power 30. What I want is coefficient of x raised to the power 30 in this. This is what I want. So if I have this, now let us try and solve this statement in the third part. So if I take first and third, they are same. And if I apply GP, it becomes 1 minus x raised to the power 31 by 1 minus x whole square. The second that I have written, I can write the sum as x raised to the power 4, 1 minus x raised to the power 4 by 1 minus x. And the third, I can write it as nothing but x raised to the power 2 into 1 minus x raised to the power 5 by 1 minus x. And what we want is coefficient of x raised to the power 30 in this. See now here, if you carefully observe, what you will be able to see is there is this x raised to the power 4 here, 3 here. So from the remaining terms, the contribution should be nothing but x raised to the power 24. So what I want is out of 1 minus x raised to the power 31 whole square, 1 minus x raised to the power 4, 1 minus x raised to the power 5 and 1 minus x raised to the power minus 4. The contribution should be x raised to the power 24. This is the coefficient that we want. In the next part, now you can see that this can only contribute x raised to the power 0 because second power would be x raised to the power 31 and that will exceed 24. So this we do not want. Rest of the things, if I multiply these two parts, what I'm getting is nothing but 1 minus x raised to the power 4 minus x raised to the power 5 plus x raised to the power 9 into 1 minus x raised to the power minus 4. In this contribution of coefficient of x raised to the power 24. And if I further simplify it, from the first term, I will have x raised to the 1 minus x raised to the power minus 4. Second one, x raised to the power 1 minus x raised to the power minus 4. Third term, x raised to the power 5 into 1 minus x raised to the power minus 4. And plus x raised to the power 9, 1 minus x raised to the power minus 4. Out of this, what I want is coefficient of x raised to the power 24 from the first part. If I write it down, it comes out to be 24
plus 4 minus 1 C24. From the next part, a minus will come. See, 4 is already gone. So we'll want 20. So 20 plus 4 minus 1 C20. Third part, x raised to the power 5 is already gone. So what we are left is 19 plus 4 minus 1 C19. And last part, again x raised to the power 9 we have to take away from 24. So 15 plus 4 minus 1 C50. If you simplify this, the answer that you get is nothing but D option, that is nothing but 430. If I look into this 2024 question is very plain and simple. It talks about number of ways of getting a sum of 16 by throwing a dice 4 times. So that would mean if the first time the dice shows x1, next time it shows x2, x3 and x4, the sum of that should be equal to 16. If you carefully observe this, here the value of x1, x2, this will lie between 1 and 6. So very important thing to notice here would be I cannot directly apply Bagger's method out of the box. And when there is a lot of customization involved in the question, it is highly recommendable that you apply multinomial theorem. So what we are going to do is, we are going to write the variation of xi. So x1 can be from 1. It can take 2 values, then 3 value, then 4 value, then 5 and then 6. Same can happen with x2, x3, x4. So let us write them. And then same can also happen with x3. And same can also happen with x4. So this is the method of multinomial theorem. We'll write the variation of x in the power of x1 in the power of x. So the variation of x1 was from 1 to 6, hence power from 1 to 6. Same for x2, same for x3, same for x4. And out of this, what we want is nothing but coefficient of what we require on the right hand side, that is x raised to the power 16. So if you want to write the answer in the next step, this is my first step, conceptualization. Now we are doing calculation. So x1 to x raised to the power 6 raised to the power 4 will come, and from here we want coefficient of x raised to the power 16. Now after this, it is a question of binomial theorem. If I want to solve this, I will write the sum. So this will become x into 1 minus x raised to the power 6 by 1 minus x raised to the power 4. So 4 will go everywhere, and out of this what I want is coefficient of x raised to the power 16. Now in order to find that, if I remove this x raised to the power 4, then the remaining part, if I write, it should contribute 4 powers less, that is nothing but what I want is coefficient of x raised to the power 12 out of this. And now you can see that this question can be done using table method, because this can be written like 1 minus x raised to the power 6 into 1 minus x raised to the power minus 4. And what we want is coefficient of x raised to the power 12. In the third part, let us make a table. So what I have 1 minus x raised to the power 4. And another thing that I have is nothing but 1 minus x raised to the power minus 4. So this first part will contribute 0. Then this should contribute 12. If this contributes 6, this should also contribute 6. If this contributes 12, this should contribute 0. Now coefficient corresponding to 0 will become 4c0. Coefficient corresponding to 6 will become 4c1, but with a minus sign, because there is a minus sign here. Then plus 4c2 in the next part. Corresponding to that, if I want to write the coefficient, you should know this result if I have 1 minus x raised to the power minus n. If you want to find coefficient of x raised to the power r, the answer corresponding to that is n plus r minus 1 cr. This is an important result and should always be remembered while doing questions based on multinomial theorem. So in the first case, the answer becomes 12 plus 4. That will become 4 plus 12 minus 1. CR, R would be 12. Correspondingly, next will become 4 plus 6 minus 1. C6. Next one would become 1. Once you have done this, we'll multiply them and add them up to get the answer. So first part, what are we getting is 4c0 into this will become 15c12. In the next part, it becomes minus 4c1 into this will become 10 minus 1, 9c6. And ultimately, it will become 4c2 into 1. If I sum it up, let us see what do I get. In the first part, what I have 15C12, so that will become 15 into 14 into 13 divided by 6. And if I simplify this will get cancelled out, will become 5. This 2 will also cancel out, will become 7. So this is nothing but 13 into 5 will become 65 into 7. That if I multiply becomes 7 into 5, 35, 3 will come. 7 into 6 is 42. This will become 455. So first part becomes 455. Next one let us find. This would be equal to 4 into 9 say 6, that is 9 into 8 into 7 divided by 3 factorial, that is 3 into 2. You can see that 3 will get cancelled out from here, and then 2 we can cancel out from here. So what we have is 6 into 8, that is 48, and then 48 times 7. So this will become 7 into 8 is nothing but 56. 5 will come. 4 into 7 is 28. 28 plus 5 will become 33. So 336. So this will become minus 336. And the last part, if I figure out, this will become nothing but 4 into 3 divided by 2. That is nothing but 6. If I simplify this, what will happen? So in form 455, I will have to subtract 360, 336. Now we can 6 we can adjust, so directly we can subtract 330. And if I do so, this becomes 5, this becomes 2, this becomes 1. The answer to this question becomes 125. Now if I look into this 2024 question, now this is a class illustration from PracBee's lecture notes. Now let us see what this question means. So see, there can be multiple ways of doing this question. Seen people using multinomial theorem to also do it in multiple books. But see, from calculation and doability point of view, it is always better in such questions to make cases. Similar kind of question was earlier asked in JEE Advanced, where you had to make cases to get to an answer. Good thing about that question was, here we are writing x plus 2y plus 3z equal to 42. The number on the other side was smaller, so there were less number of cases. Now let us look into this question. So you will have to make cases. How to make those cases? I will show you one case, then write an algorithm to calculate all the cases at the same time. So if you take z equal to 0, what will happen? X plus 2y now will be equal to 42. Now see, x is nothing but a whole number, y is also a whole number. So you can see that the minimum value of y that you can put is 0. Corresponding to that, the value of x will become 42. On the other hand, we can keep on doing this. I can put y is equal to 1 also. If I put y is equal to 1, correspondingly 2 terms will get reduced from the other side. So x will become 40. There is no problem with x. Only problem is with y, because y when multiplied by 2 will generate a even number. So correspondingly x will take automatically values. So you can see that the highest value of y that you can put in this case is nothing but 21. And corresponding to that, the value of x will become 0. So in this case, you can see there are total 21 plus 1 case. That is nothing but 22 cases. Now, if you have observed this fact, rest of the cases will become easy. In the next part, I will show you one more time. If I put z is equal to 1, now what is going to happen? The value of x plus 2y corresponding to this will be 3 less, it will become 39. And the maximum value of y that can occur can be now 19. And from y is equal to 0 to 19, we will have total 20 cases corresponding to this. Now see, this has become a process. So we start with 0. Now let us make it into a process and write the remaining cases. So what I can do is I can start with z is equal to 0. And corresponding to that, if I want to find cases, it will be nothing but 42 divided by 2. Greatest integer function plus 1. This was the answer, because we ultimately divided 42 by 2 and got 21. From there we are getting our 21 cases, and plus 1 I have added for the 0 wala case. Correspondingly, if I want to write the answer for the next part, it will become nothing but from 42 I am subtracting 3. So that will become 39. Divided by 2. Put a greatest integer function plus 1. This is the answer for the next case. Similarly, we can keep reducing 3 from the numerator, divided by 2, put a greatest integer function and add 1. We can keep on doing this. So this will become 33 divided by 2, greatest integer function of x plus 1. Then 30 divided by 2, greatest integer function of x plus 1. Then 30, then it will become 27 divided by 2, greatest integer function plus 1. We can keep on doing this. In the next part, we can start with again 3 less, that will become 24 divided by 2, greatest integer function of x plus 1. And let me write the next one using a different color so it is easier to understand. So 21 divided by 2, greatest integer function of x plus 1. Next, we will again reduce it by 3 and this becomes nothing but 18 divided by 2 plus 1. And again we can reduce it by 3. So it will become 15 divided by 2, greatest integer function of x plus 1. Next it will become nothing but 12 divided by 2, greatest integer function plus 1. Then 9 divided by 2, greatest integer function plus 1. Next we can move in the next part and write again reduce by 3. So 6 divided by 2, greatest integer function plus 1. And then 3 divided by 2, greatest integer function plus 1. I can still reduce 3. So this will become 0 divided by 2, greatest integer function plus 1. Now if I count this up, it will add up to nothing but 169. Now this very interesting question came in 2024. This question caters to the category that I told you earlier, that when I am doing distribution, objects and the things it is getting distributed into can have 4 categories. So distinct objects, distinct categories that we are trying to this was the first kind of question that we did. Then distinct and this became identical. This also we looked into. This is known as distribution into groups. First was distribution into person. The third category became when we have identical things and distinct categories. This would come under the category of binomial, Beggar's method, and then multinomial theorem. Now we are moving towards the fourth category. Both are identical. Now this kind of questions can only be tackled by making cases. So none of your methods that you have learned earlier will get applied. Now in this question, what we can do is we can make cases. So what are the possible cases that are possible? So let us start. So first case would be, let us start with the maximum, and while making cases it is important to follow some logic. Like in this case, the logic that we are going to follow is, we are going to start with maximum. So I can have 800. Now this cannot be further have multiple types because books are also identical, shelf are also identical. So this will become a case in itself. Second part that will have is, if I reduce this 8 to 7, then I will have 1 left. So one book we can write. So 7100, this is another possibility. Third is, if you take this 7 and make it 6, then you can have 1, 1 and 0. This can also be in turn written as 6200. This is another possibility. Then fifth part could be, now what I can do is I can make this 5. Then what can happen is 5, 1 and 1 can happen. And then 5, 2, 1, 0 can also happen. Or we can have 5, 3, 0, 0. This can also happen. Moving further, I can have an 8th type and I can make this 4. If I take this to 4, so 4, 1, so I will have to take 1, 2, otherwise it will not add up. If you follow the same pattern and write the remaining cases would be nothing but 4220, 4310, 4400. So what I am doing is I am slowly increasing what is along with 4 by 1 and adjusting the remaining cases. Similarly, I can do it with 3. So these 3 cases I will get, and the last case would be nothing but 222. So in all you are getting 15 cases.
Now let us look into next problem type, that is nothing but circular permutation. Now usually in this you will see 2-3 types of question. One is n objects and distinct objects are given to be arranged in a circle. So your answer becomes n minus 1 factorial. Another thing is, if you want to arrange this n distinct objects in a 3D circle, so what you have is a 3D diagram, then you won't be able to distinguish clockwise and anti-clockwise, and your answer becomes n minus 1 factorial by 2. Apart from this, there are questions which are based on string method. Then there are questions based on gap method like we saw in the case earlier, and then destruction. So these type of 5 questions have generally been based on this idea, but largely speaking, these 3 questions have been more important in JEE exam. Now let us see what was the question that was asked in 2023. This 2023 question talks about 5 girls and 7 boys be seated in a round table so that no 2 girls are together. So what you can do is you can make a circle and seat these 7 boys first. So boy 1, boy 2, boy 3, boy 4, boy 5, boy 6, boy 7. Like this we can seat them. Now the number of ways. So the first idea is we are arranging boys in a circle. Then we'll find gaps. And then we are going to put girls there because no girl need to be together. So this is the thinking process that we are trying to follow. So arranging 7 boys in a circle is n minus 1 factorial. So 7 minus 1 factorial. Now in a circle, when you are taking 7 objects, there are going to be 7 gaps only. So this becomes 7c 5, and then you can arrange your 5 girls here, 5 factorial. If you simplify this, this comes out to be option D, that is 126 into 5 factorial whole square. Now let us move towards the last problem type, that is dearrangement. Now usually what is a dearrangement? To dearrange is nothing but a terrorist idea of arrangement. So what does that mean? I will take a very simple example, and if you remember this example, you will get your question right based on dearrangement 100% of time. So let us say that you went to a temple with 3 friends, Raju, Mohan and Shyam. These 3 friends went to a temple. Now, what happened in the temple is basically when they came out, Raju saw that the Mohan's chappal are very beautiful compared to his one. So Raju took Mohan's chappal. Then Mohan came out and he figured out that his chappals are not there. But there is one chappal that looks decently good, and then that is of Shyam. So Mohan took Shyam's chappal. And then Shyam came out and there was no option, so he took Raju's chappal. So what happened is that they came with their own chappals, but they went wearing each other's chappal. So none of the chappal was in the feet that was originally intended. Now this is known as dearrangement. So if you keep this idea into brain, you will be able to solve most of the questions. Apart from that, we have already derived a formula based on dearrangement. So that formula is, if you want to do dearrangement, then the answer is nothing but dn. It is nothing but dearrangement of n objects, and it is nothing but n factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial, and it will go till minus 1 raised to the power n by n factorial. So you can see that in this case, if you want to find d3, the answer becomes nothing but 3 factorial into 1 minus 1 by 1 factorial. You will go till 3, and there you are going to stop. If you simplify this, you get your answer. It is not very difficult because first 2 terms get cancelled out. So 2 is your answer. So it is very simple to calculate this. This is the first type of question that are usually based. Another type of question that you will find in a JEE Mains exam is, they will talk about few objects. So let us say that instead of 3 people, there were 5 people initially. And now what we are saying is 3 of them got their chappals correctly and 2 of them faced some problem. So they went into 2 incorrect people. So if this happens, so what we are going to do in this case is, out of this 5, choose 3 and give them to right people in one way. And for the remaining 2, apply dearrangement. So this is again a very simpler concept that you can use in solving JEE Mains question. Now let us see what kind of JEE question was framed in 2023. The question says that there are 5 students who have been allotted their seat as per row numbers. The number of ways, now let us go to the question, number of ways in which none of the students sit on the allotted seat. This is nothing but a classical definition based dearrangement. If you remember the temple example, you will be able to get it right in the first instant. So you can see that your answer is nothing but d5, and you put the values, becomes 5 factorial, 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial and minus 1 by 5 factorial. And if I simplify this, first 2 terms get cancelled out. So it is nothing but 5 factorial by 2 factorial minus 5 factorial by 3 factorial plus 5 factorial by 4 factorial and minus 5 factorial by 5 factorial. So simplification if I do, first part becomes 5 into 4 into 3. The second becomes 5 into 4. The third becomes 5. And the last becomes 1. So 5 into 4 is nothing but 20. 20 into 3 is nothing but 60. 60 minus 20 plus 4. And this becomes nothing but 44. And that is nothing but our answer.
It is a very simple question. Direct identification of dearrangement needs to be done.
If you like this video, you will also like PracBee's unique one-on-one last mile journey program. In this program, we sit with the student, understand their preparation till this point of time, and based on that, in step 2, we write a customized planner just for you to help you optimize your marks in JEE Mains exam based on whatever preparation you have done. In the step 3, we sit with you one-on-one by a set of faculties aligned by PracBee and help you implement the customized plan that we wrote for you. Students have come to us with limited no or good preparation and all have been able to score their marks to a large extent. Ashish, using this program, was able to improve his fortunes by lot, starting from 95 percentile in JEE Mains attempt 2 to getting selected for mechanical in IIT Madras. Ditya, over a period of time, was able to crack into JEE Advanced using this program. If you think that this seems interesting to you, click on the link below in the description, fill the required details and somebody from my team will get in touch with you.